Erasmus has rightly said, and I quote, "The main hope of the nation lies in the proper education of its youth." A showering and blessed good morning and a hearty warm welcome to our respected chief guest, the distinguished speaker of the day, the executive members of Indian Association of Physics Teachers, Regional Council 1, and my dear participants and virtual audience present over here. I am Dr. Poonam Jain, your host and executive council member of IAPT. Welcome you all for the day 1 of 10th annual convention of Indian Association of Physics Teachers, RC-1 and RCIEP 2022. The themes for today's convention are experiential learning and integration in physics, competency-based questions in physics, use of online tools or teaching methods, or low-cost experiments in offline teaching. I would first like to pay my sincere gratitude towards Professor Krishan Lal sir, former director, National Physical Laboratory, co-chair in IAP for Sciences, the Global Network of Sciences Academy, New Delhi, for gracing us with his presence as chief guest on this auspicious event. Also, I would like to welcome our renowned speaker of the day, Professor P.K. Ahluwalia sir, the President, IAPT. Now I would like to welcome Professor Y.K. Vijay sir, the Director, Center for Innovation in Science Teaching, IIS deemed to be University, Jaipur, our innovative professor. Dr. O.P. Sharma, Director, NCIDE, IGNOU, New Delhi. Past President, Professor V.P. Srivastava, past Secretary, Dr. Bhandari, and all the other distinguished professor members of IAPT RC1 and our virtual audience present over here. Before we begin, this is to inform you that this session is being recorded. Before proceeding ahead, I request all the participants to mute their mics during the session for the smooth conduct of the event and drop your questions related to the lecture in the chat box. One more important announcement for the participant is that the time allotted for the paper presentation is 15 minutes. Further bifurcated as 12 plus 3 minutes, that is 12 minutes for the talk and 3 minutes for the question and answer session. I request all the participants to kindly complete their talk within the allotted time so that our moderator can take the queries related to your talk, if any. All the participants are now kindly mute yourself during the whole session for the smooth conduct of the session. Without further ado, now I request Dr. Yogesh Kumar, the Secretary IAPT RC1, for the welcome and introduction about IOPT. Over to you, sir.
Thank you, ma'am. Am I audible to everyone?
Yes, you are, Yogesh. Can continue.
Yes, sir, you are.
Okay. Thank you, Poonam ma'am. Greetings to one and all. It's my great pleasure to welcome you all for the 10th annual convention. On the behalf of IAPT, I, Yogesh Kumar, Secretary, IAPT RC1, welcome our wonderful audience. Today, we are delighted with the presence of our chief guest, Professor Krishan Lal sir, former Director, NPL, Professor Y.K. Vijay, Director, CIST, Jaipur, Professor C.K. Ghosh, former Director, NCIDE, IGNOU, Professor P.K. Ahluwalia sir, President, IAPT, Dr. Rekha Ghorpade ma'am, Secretary, IAPT, Professor V.K. Srivastava, former President, IAPT RC1, Dr. O.P. Sharma sir, ex-officio President, IAPT RC1, and other distinguished professors present here. I also welcome faculties from various schools, colleges, universities from different parts of India Also, I welcome members of IAPT, DSSTF, and all other participants. Now I would like to introduce about this organization, Indian Association of Physics Teachers, a major and well-reputed organization established by late Dr. D.P. Khandelwal in the year 1984, has a local chapter in every state. IAPT RC-1 is a chapter of IAPT for Delhi and Haryana region. We organize various activities for the promotion of physics and physics education. Briefly, I want to mention some major activities of IAPT. First, IAPT conducts 2 national level examination, National Standard Examination in Physics and National Graduate Physics Examination. NSEP leads to participation in the Asian Physics Olympiad and the International Physics Olympiad. IAPT promotes setting up Anvishka in different schools under each RC. These Anvishkas are part of the National Anvishkas Network of India. IAPT organizes several workshops on activity-based teaching learning in different schools and colleges. IAPT brings out 2 important periodicals, IAPT Bulletin and Physics Education regularly. And the bulletin is circulated among its members free of cost. IAPT organizes an annual convention, which is an open for all members of IAPT, and they are free to attend and present their experiences in the form of paper, poster, etc. Sometimes national student symposia on physics are also organized to provide a forum for students engaged in innovative and investigative projects. In IAPT Regional Council 1, we arrange workshop for physics teachers and students, orientation of teachers and students for NSEP and NGP examination also will be conducted. We conduct NSEP and NGP examination. We organize Professor Vedratna Memorial Lecture, regional competition on innovative experiment in physics, regional competition on innovative in computers for physics. We organize regional annual convention. We also arrange lectures by eminent physicists all over the world, celebrate the days of scientific importance. We undertake research on science teaching and also develop of resource material for physics teachers and students. In this pandemic COVID-19, we have successfully conducted many important lectures for students and teachers all over the world. To this end, we are proud member of a family in which everyone is willing to share his and her knowledge and experience with others. With these words, on the behalf of entire physics fraternity, I welcome you all and wish a grand success of this event. Thank you very much. Over to Poonam ma'am.
Thank you so much, sir. You have introduced the participants about the activity conducted by IAPT to all the newly added members as well. Yes,
Poonam, there is a echo in your voice. Just correct it. I mean, I don't know.
There is an echo.
Yes,
Yeah.
I think the 2 devices are on. That's why.
Now is it fine, ma'am?
Yes. It's okay, ma'am.
Thank you so much, sir, for introducing about the activities conducted by IAPT to all the newly added members and participants present over here. Now I request Dr. S.K. Singhal, Treasurer IAPT RC-1, for introducing today's program to our participants, audience, and the guests present over here. Over to you, sir.
Thank you, Poonam ma'am. A very good morning to all and everyone present today. Respected Chief Guest, sir, Professor Kishan Lal, sir, former Director NPL, Professor P.K. Alwalia, sir, National President IAPT, Dr. O.P. Sharma, sir, former President IAPT RC-1, Director NCID IGNU, New Delhi, Dr. Seema Was, President IAPT RC-1, Professor Y.K. Vijay, sir, Director Center of Innovation Science Teaching, CIST, Jaipur, Dr. Yogesh Kumar, Secretary IAPT RC-1, Dr. M.S. Bhandari, sir, EC member IAPT RC-1, Professor V.P. Srivastava, former President IAPT RC-1, Professor H.K. Sejwani, sir, EC member, Sri Sujan Singh, Vice President IAPT, Dr. Manoj Kaushik, Dr. Poonam Jain, and all EC members of IAPT RC-1, distinguished guests, teachers, and students. Today, IAPT RC-1 is organizing its 10th annual convention, and myself, SK Singhal, Treasurer of IAPT RC-1, apprise you about this program. This is a 2 days program. Today is the first day of this program. The program flow is like that. Just after this, there is a video presentation of Professor D.P. Khandelwal by M.S. Bhandari sir. And after that, our president of IAPT RC-1, Dr. Seema Bas, will introduce our chief guest, Professor Kishan Lalji. After that, 10:25, the remark by Dr. O.P. Sharma sir. Then 10:30 a.m., our chief guest, sir, will address to all participants. 10:50 a.m., the vote of thanks will be given by our Vice President, Sri Sujan Singh ji. After that, there is a talk by Professor Y.K. Vijay sir, Director CAST, on innovative experiments in Hub. At 12 noon, the talk by Professor P.K. Ahluwalia sir on the topic use of classroom as research laboratory physics education. Then 12:30 onward, we will start the paper presentations, which is judged by the IAPT, and the paper will be presented by Dr. Anil Kumar sir, Professor Punita Verma, Professor Pushpa Bindal, and Ms. Monica Sindhwani. This is the 2 days program of IAPT RC-1 in the 10th innovation. And tomorrow we have second day, in which we start the program at 10 a.m. And we start the program by the talk by Professor C.K. Ghosh sir, former director NCID, IGNU New Delhi, on some thought on learning of physics in the light of recommendation of NEP 2020. Then 10:30 a.m. the talk by Professor Mahesh Shetty sir, Department of Physics, Wilson College, Mumbai, on the topic building competency in the scaling and order of magnitude estimation. And after that, there is a presentation on innovative and hands-on experiment by Dr. S.K. Singhal. At 11:30, the presentation of participants of innovative experiment will start, which is judged by Professor H.K. Sejwani sir and Professor V.K. Vijay sir. After that, at 2 p.m., the result will be declared by esteemed judge. 2:10, the vote of thanks will be given by our Vice President, Professor Sri Sujan Singh ji, Principal, ITBP School, Dwarka. So I also tell you our webinar team, Dr. Poonam Jain, Dr. Yogesh Kumar, Dr. Manoj Kaushik, and Dr. S.K. Singhal. Thank you to all of you. Have a nice day. Over to Poonam.
Thank you, sir, for sharing the details of 2-day annual convention with all the participants so well. The busyness of Dr. M.S. Bhandari in the examination, so he is not available right now. So we will move further. Now among us, we have Dr. O.P. Sharma, Director NCIDE, IGNU, New Delhi, who will enlighten us with his remarks about today's activity. I welcome you, sir, and request few words from you. Over to you, Sharma, sir.
Thank you, Dr. Poonam. Good morning to all. Respected chief guest of today's program, Professor Kishan Lalji, Professor P.K. Ahluwalia ji, Professor Y.K. Vijay ji, Professor Rekha Borpade ji, Professor V.P. Srivastava ji, Yogesh ji, Singhal ji, Dr. Seema Bas, and all the dignitaries and participants who have joined this program today. This annual convention of IAPT, which was started 10 years back in 2013, basically had a very special purpose. That purpose was aimed at connecting the members of IAPT, bringing them on one platform. That was the objective, because we know many of physics teachers are associated with the IAPT, particularly the Regional Council, Delhi and Haryana. And we noticed that we did not meet frequently And in fact, not frequently, there was no platform to meet the members of IAPT in such a way. So that's why this kind of initiative was taken in 2030. And I'm here very pleased to share with you that that time, the first annual convention, which was organized in the National Bal Bhavan, in that too, Professor Kishan Lalji was the chief guest. So we are really thankful to you, sir, for your blessings and your guidance, which we have been getting from you in different other programs. Also, you have joined. And since then, the Regional Council, Delhi, Haryana is organizing this annual event regularly. For that, I would like to congratulate and appreciate the work of the Regional Council, RC, Delhi and Haryana, under the leadership of Dr. Seema Bas with her team. Really, it is a very good opportunity for all of us to come on one platform, share our thoughts, share our work, and learn from each other. So this kind of initiative taken by the Indian Association of Physics Teachers, Regional Council, Delhi and Haryana, 10 years back is now continuing, and hopefully it will continue, and we will be listening to such eminent persons, and listening to such eminent persons. Their work is always very, very good for all of us. It is a learning to all of us. In fact, this kind of initiative should be taken by other regional councils also. The Regional Council, Delhi and Haryana has been taking this kind of initiative that has brought many teachers not only on this platform, but they have joined the IAPT also, because they are now aware of the IAPT activities that IAPT is organizing. Many such programs which are of use for them, which are very informative and knowledgeable for them. We are bringing many eminent persons. They are sharing their thoughts and experiences. So with that, I would like to thank and congratulate the Regional Council team for organizing this 10th annual convention of IAPT RC1. Thank you very much, and thanks to all the participants also, and thank the organizers for inviting me and share my thoughts on this occasion. Thank you very much.
Thank you so much, sir, for your blessings and the kind words. Today, we are honored to have Professor Kishan Lal, sir, the former Director, NPL, Co-Chair, IAP for Sciences, the Global Network of Science Academy, New Delhi, as chief guest. First of all, I would like to request Dr. Seema Bas, President IAPT RC1, to introduce and invite our chief guest. Over to you, ma'am.
Thank you, Poonam. It gives me an immense pleasure to express my deep regards to our honorary chief guest, Professor Kishan Lal, sir. And it's a matter of great pride to introduce him for this annual convention. He is a co-chair in Indian Association of Physics for Sciences, the global network of science academies. He is also a C.V. Raman chair professor at K.R. Mangalam University, Gurugram. He was a former director of CSIR, National Physical Laboratory in New Delhi, from 2000 to 2005. He had also been appointed as CSIR Emeritus Scientist, INSA Senior Scientist, DST Ramanna Fellow, Law Bragg Chair Professor, MIT University. He is also an honorary professor for life at University of Delhi, honorary professor at IIT Kanpur, and visiting professor at Punjab University, Chandigarh. His list of awards and honors will take a day's time. But to name few of them, I would like to mention that he has won D.S. Kothari Memorial Lecture Award in 1996 by INSA, INSA Jawaharlal Birth Sanitary Visiting Fellowship Award in 2014. He has also been honored by Prime Minister of India during inaugural session of Indian Science Congress in 2014. He is a member of External Review Panel of International Council for Sciences, that is ICSU, now rechristened as ICS. He has also won S.K. Mitra Birth Sanitary Gold Medal at Indian Science Congress in 2007. He has remained a president of various societies, to name few are INSA, ICSU core data, AASSA, that is the Association of Academics and Societies of Sciences in Asia. He is the editor of Journal of Crystallography, that is the GTRIF for crystallography. He has more than 100 research publications in referred journals, 7 patents, and he has edited 9 books. Last but not the least, he deserves a special mention of his prestigious positions abroad. IBM, he has remained as IBM Indian Fellow, Thomas J. Watson Research Center, New York, visiting professor at University of Tokyo, Technical University at Darmstadt, senior visiting scientist at PTB, Braunschweig. He has also been awarded honorary doctorates by Russian Academy of Sciences in 1998 and by Assam Down University in 2017. His research interests include solid-state physics, material crystallization, crystal growth and lattice perfection, instrumentation, high-resolution X-ray diffraction, quality management. So, he is a genius in all respect. And he has always taken the path less traveled. That is the key to his greatness. We welcome you, sir, and please enrich us and enlighten us with your insightful talk. Thank you, sir. Over to you, sir.
Thank you very much. Seema ji, you have always been very enthusiastic, and I recall many meetings with you, and very deeply impressed with the keen interest in educational matters. And IAPT, I congratulate, because it is at the ground level, at the basic level, when we enthuse not only students, but also potential researchers in future to pursue different areas of science and contribute something significantly. One small thing I may mention, I grew up at Meerut. We had, in Meerut College was very well known once, Professor Murli Manohar Joshi, when I was director in director conference, he mentioned about Professor Roop Kishore, who was a student of C.V. Raman. And because of him, C.V. Raman visited twice Meerut, and he always brought this thing. Why I'm mentioning, even when I joined NPL, often he would visit and see what I am doing. So a teacher always is there, also acts as a sort of inspirer, guide, and tells you that you should continue to do this thing. So today I have prepared a short lecture for you, and let me see if I can load it in a moment. आ जाना भाई. Can you see it now? Can everybody
no,
see it?
No, sir. Poonam, can you help, sir? No, sir.
नहीं दिख रहा.
Sir, you again
फिर
share.
से लोड करता हूँ. शेयर
सर आपने
करने
शेयर
में
स्क्रीन
तो
नहीं किया, शेयर स्क्रीन नहीं किया अभी. स्क्रीन शेयर नहीं करा सर आपने.
Sir, you first open the document and then share.
अच्छा ठीक है, ये भी ट्राई करता हूँ. Can you see it now? No. अच्छा, अब मैं फिर शेयर करता हूँ.
स्क्रीन शेयर आपकी तरफ से होगी सर.
शेयर तो है नीचे.
इसको क्लिक कीजिए सर, वो जो ग्रीन बटन है ना.
हाँ, वो नीचे दिख तो रहा है मुझे.
तो उसको क्लिक कर दीजिए. फिर ऊपर एक बार आएगी, उसमें ऑप्शन आएगा share now.
शेयर नाउ नहीं आया है, तभी तो मैं भी देख रहा हूँ। ये तो बहुत करना पड़ता है ये।
हाँ आया।
Yes, sir.
आया?
ओके सर, हो गया
Yes.
हो गया हो गया, शेयर हो गया।
हो गया?
जी जी।
Can you see it?
जी यस सर।
प्रेजेंटेशन चलाइए।
अब ये तो कुछ नया नया काम करता रहता है।
इसको सर मिनिमाइज कर दीजिए, फिर प्रेजेंटेशन पीछे आपकी होगी इसके।
हाँ इसको
इसको सिर्फ मिनिमाइज
So minimize करिए सर,
मिनिमाइज कर।
अच्छा,
इसको सिर्फ मिनिमाइज कीजिएगा, बंद मत कीजिएगा, बिकॉज ये कनेक्शन बंद हो जाएगा।
हाँ
सर सेंटर येलो वन, येलो।
अब
I
ठीक है,
should
ठीक।
see the lecture ना। Now, हाँ है या
राइट हैंड साइड एक रो।
या तो है, वहाँ उसमें आया था उसमें। Can you see it now?
आ गया।
No no,
यस सर,
it is
यस सर,
visible.
यस
You
सर।
can see it.
Yes,
Very good.
तो इसको
Slide show
visual
कर
पे
दीजिए
कर
इसको।
दीजिए।
ठीक है? Okay. Now I want to share with you that when you work under different environments, right now I am also associated, as was mentioned, with the private university, and Professor Dinesh Singh, many of you are familiar, he is the chancellor. He insisted I joined there as a C.V. Raman chair professor. So I said, how can you develop facilities even under handicapped situation, very few situations? When we started our career at NPL, importing things was not possible. But we had people like Professor A.R. Verma, and I did not mention, but very closely with the discussion with Professor D.S. Kothari. Though he was also being a Jain by enthusiastic, he had a way of contributing without gaining something for himself. This I feel there was nobody better than him in India. He never, in fact, when he became UGC chairman and so on, all secretaries posts, he never took money more than that of a professor. He said, I should honor the professorship. This is the highest body. I should not accept. That is the type of people we had. Now, I would say some of the landmarks in my life. NPL had been the key organization where I flourished and made many, many contributions. So one of the things with us was that what can NPL and our group do to promote semiconductor technology? So one of the things we understood, if you want to convert a crystal into device, is it okay?
Yes sir, yes sir.
So-
Please continue. Please
Okay.
continue.
Please
अच्छा,
continue.
ठीक है.
So
So this was there that you should have facilities, not only preparation, but must also be able to accurately determine composition and what are the purity, impurities and their quantification, the structure, because like in diamond, you can change from the normal carbon to a diamond structure and imperfection. In this, I may also visit because of a special reason. Now, last year, one of my long-standing collaborator, friend, family friend, Stefka Paneva, she came from Bulgaria, worked for her PhD with Professor Verma, and she studied whisker crystals, and that is how my crystallography work started, because I said their most fundamental paper has some problems, and initially people did not agree with me, but we could improve and publish in Journal of Applied Physics, and Stefka remained very closely associated with our group and also with our family. For example, anytime she had a problem, she will go to my mother. She had that kind of relationship. Then came Dr. Verma said that now you should develop X-ray diffraction topography, where the main thing is if you have one dislocation, you should be able to photograph. I will show you one or two pictures later. So when we did this had not so much impact in India. Many people claimed I had also made. So when this had made, I wanted to see what is their result. Can you show me a result with this apparatus you built? So there was no result. But it had a very major impact internationally. Then somebody came from IBM Watson Research Center in New York. He collected my biodata in the office of Dr. Verma. And within 3 months, I got an invitation to be there at IBM, and I remained associated with them except for last few years, this COVID, etc. Otherwise, I could anytime go there and so on. Then at the same time, NPL had a very strong interaction with the German National Lab for Measurements, PTB. And in fact, they had contributed a lot to set up new laboratories in NPL. And one of the times Dr. Verma showed them the results I got on sapphire crystals, which I had brought from IBM. So German people became very, very shocked. And they said, हमारे भी कुछ कर दो. तो हम लोगों ने किया, उससे फिर हमारा वहाँ बहुत लंबा collaboration चला. At one time, Braunschweig was also like my second home. They invited me, my family, and so on. Then in this meanwhile, I had an invitation from Japan, Professor Kohara. He was a student. The Japanese did one very wonderful thing India could not do. They sent their very talented professors to, say, for example, Nobel laureates. So Kohara Saab went to Lowe's lab in Germany. So when I was invited there, I was also a little tense, but gradually I showed that our experiment had some features additional. So lifelong, I had a very good contacts with them. So in this, then we put one more thing. While I was visiting PTB and their president invited me, there was some problem given by the government. So I said, we can do experiment to show if you put electric field, what will happen in the crystal we started doing. Then there was also a very big discussion with some of the top people like Professor Doris Wilsdorf. Everybody was scared in India. She had a student, but she came to NPL to visit everything. But then she decided only to spend time in our group. And we had very long association and very positive association. Then we started developing diffuse X-ray scattering. This was initially a suggestion by Verma Saab because he said lot of people are doing diffuse scattering, but I don't understand what they are. So we started the high resolution measurement, and Doris Wilsdorf, he became very, very excited about it. And finally, we thought that we have to improve our system. So we developed a 5-crystal diffractometer. It still is a record in terms of resolution. Recently, when I shifted to Gurgaon, this Mangalam University, I will show you what you can do when you have no resources. This is what I will show a little bit later. So when you want to develop societies like India, we want to use science and technology, but technology should lead to production and prosperity. India, we did not bother. अगर हमें समझ आ गई ना कोई चीज हम बड़े खुश हैं. We did not lead it to production. Till it leads to production, which is happening now in big India, prosperity will not come. This was a good example in Japan, Korea. I have seen directly with them. So this is a very important lesson one has to learn. Now, today, what is happening is that this is an era where artificial intelligence not necessarily dependent on human being, but intelligence put into advanced computers or the machine language so that the computers can talk to each other, and the quantum computation. This is no longer the bits by bits, and this is a advanced combination of software and hardware. One of the most remarkable example recently was when a Mars probe in last 15-20 seconds was on its own. There was no connection with the Earth, because if the signal time taken by the signal to go and back, it would be destroyed if it is not done properly. So this is, we are only singing their song. I am only mentioning, nothing will come to us if we keep on only उसकी तारीफ ही करते रहेंगे, उसका भजन कीर्तन करते हैं. हमें खुद बनाना पड़ेगा. जब तक खुद नहीं बनाएंगे, कुछ हद तक इस सरकार ने कोशिश की है, मैं ये कहना चाहता हूँ. सो जो रिसेंट डेवलप्स हुए हैं, अब मैं 2-1 मिनट चूंकि एनपीएल का डायरेक्टर रहा हूँ, थोड़ा वो भी बता दूं, क्योंकि पता नहीं आप लोग पढ़ाते हैं कि नहीं. रिसेंट में कुछ मेजरमेंट साइंस में भी बहुत चेंज आए, जो कि टेक्निकली वर्ल्ड वाइड. तो 2-1 मिनट उस पर लगाऊंगा. जैसे 20 मई 2019 में यूनिट की डेफिनेशन में चेंज आया. 20 मई 2009, 20 मई इज ए मेट्रोलॉजी डे. ये मीटर कैसे डिस्कवर हुआ, आज उस पर नहीं बात करूंगा, लेकिन ये नोन है. अब उसका क्या हुआ कि जो हमारी ये बेस यूनिट है, वो सारी आपस में कनेक्टेड हो. मास, लेंथ, टाइम, एम्पियर, कैंडेला, ये अब ये आपस में कनेक्टेड है. ये हुआ अभी है 2019, यानी हम बहुत दूर नहीं है उससे. अच्छा, दूसरी ये है कि आज हम जिस जमाने में रह रहे हैं, जो मैं कह रहा हूँ, इसमें मैन मेड मटेरियल, चिप्स, इनका बहुत बड़ा जोर है. अगर ध्यान से देखें, आप एक पाउडर से शुरू करते हो, उसको मेल्ट करते हो, उसका क्रिस्टल बनाते हो, उस बूल को काट काट के छोटे छोटे वेफर बनाते हो, फिर इन वेफर को आप प्रोसेस करते हो. अब क्वेश्चन ये है, ये हमारे यहाँ वीकेस्ट पॉइंट, कि आपने वेफर ले लिया, तो आप रिप्रोड्यूस करना है, तो क्या क्या आपको करना चाहिए कि रिप्रोड्यूस हो जाए बिल्कुल वही प्रॉपर्टी के साथ, या इसका डिवाइस जो मैं बनाना चाहूँ वो बार बार वही बने. तो इसके लिए जो मैं कह रहा था, प्योरिटी और उसका जो स्ट्रक्चर है वो सफिशिएंट नहीं है, उसमें डिफेक्ट की नॉलेज भी आना बहुत जरूरी है. इसके लिए हम लोगों ने हाई रेजोल्यूशन एक्सरे डिफ्रैक्शन, हमारा आज भी वर्ल्ड वाइड इसका स्टैंडर्ड है. बहुत सारे लोग अभी भी इसको यूज करते हैं. बेसिकली ये हम हाई स्कूल से भी पढ़ते हैं आजकल, मतलब अंडर ग्रेजुएट से, कि ब्रैग ज्योमेट्री नोन थी हमें, और लेकिन हमने इसको एक्सट्रीम में ले जाके 5 क्रिस्टल का डिफ्रैक्टोमीटर बनाया. उसका मेन पर्पस ये था कि जो एक्सरे बीम है उसकी वेवलेंथ प्योरिटी और डाइवर्जेंस बिल्कुल थियोरेटिकल लिमिट से भी नीचे ले आए. जो नॉर्मली आम जो डिफ्रैक्शन कर्व होते हैं वो 3 से 5 सेकंड ऑफ आर्क थे, तो आपका एक्सप्लोरिंग बीम उससे कम होना चाहिए. फिर दूसरा ये, जो डिफ्रैक्ट हुआ है उसको एनालाइज करने की भी कैपेबिलिटी आप में होनी चाहिए. ये एनपीएल का है. तो ये जैसे हम लोगों का ये अभी भी स्टेट ऑफ द आर्ट है कि आप 3.43 सेकंड्स का हाफ बिट का सिलिकॉन का पीक लें, और ये हम रेफरेंस की तरह से यूज करते हैं. क्या हो गया, नाराज हो गया, अभी कुछ कर रहा है, क्या हो गया भाई?
स्लाइड्स ब्लैंक है शायद सर,
है?
कुछ स्लाइड्स ही 2-3 स्लाइड
आगे
ब्लैंक
की
है.
स्लाइड्स ब्लैंक दिख रही हैं सर.
अच्छा, देखता हूँ, आगे चल के देख. चलो ठीक है. अब एप्लीकेशन क्या करना है कि आपको पहले तो कोई दे तो पता चले मटेरियल क्या है, क्रिस्टल है, पॉलीक्रिस्टलाइन है, कुछ इसमें अगर है क्रिस्टल तो डिफेक्ट कौन से हैं, फिर उसको आपको क्वांटिफाई करना. इसकी बहुत सारी टेक्निक है, वो मैं आप लोगों को जान के अवॉइड कर रहा हूँ. मैनी ऑफ यू आर वेरी नॉलेजेबल. पर मेन चीज़ ये है कि आप अगर थिन फिल्म हो और क्रिस्टल हो, आपको कुछ करना आना चाहिए. और थिन फिल्म का मेरा मतलब, अब ये माइक्रोमीटर और नैनोमीटर, आजकल फ्यू एटॉमिक लेयर की थिकनेस का इशू, ये हम लोगों को काफ़ी चैलेंजिंग था, और वो भी हम लोगों ने काफ़ी डिटेल में किया. और जैसे बल्क क्रिस्टल तो है ही, थिन फिल्म सिंगल क्रिस्टल, एपिटेक्शियल है। फिर अगर डिवाइस बनाते हैं तो उसकी लॉन्ग टर्म स्टेबिलिटी क्या होगी, कि वो जाते ही खराब हो जाएगी या 2-4 साल चलेगी, कि हम लोगों का काफी, ये मैं छोड़ देता हूँ। अब एक में उसकी फोटो नहीं आ रही, पर चलो, एक बिस्मथ जर्मिनेट क्रिस्टल, क्योंकि ये मोर एडवांस डिवाइसेस में जा रहे थे, तो इसका ये था कि डिफरेंट, व्हेन यू एग्जामिन ए क्रिस्टल, आप एक पॉइंट पे नहीं करते, आप उसके अक्रॉस द विड्थ करते। तो इसमें क्या था कि एक पॉइंट पे, जैसे जो यहाँ सर्कल के टॉप पे अगर देखें, तो वहाँ 2 पीक, तो सेंटर में बिल्कुल ठीक था, 4-5 सेकंड का था, वी कुड पब्लिश द पेपर, बट वी सेड नो। पूरा देखा तो ऊपर बीच में ये आधा मिनट 33 सेकंड का डिफरेंस था, बट वी कुड रिजॉल्व, दैट इज व्हाई वी कुड सी। फिर यही देखा ही नहीं इसको, उस वक्त इस जो बाउंड्री है इसका कोई नाम नहीं था लिटरेचर, nobody knew। लो एंगल बाउंड्री मीन्स 1 मिनट के करीब है या उससे कुछ मिनट्स में, हम सेकंड्स में आए। वी गेव ए न्यू नेम, वेरी लो एंगल बाउंड्री, जब 100 सेकंड से कम थी। अब इसमें यह है कि आपने फोटो लिया, रिकॉर्ड किया टोपोग्राफ, दोनों पीक्स पे अलग अलग, और उन दोनों को आप देख रहे हैं। जैसे राइट हैंड साइड पे मोस्ट ऑफ द पार्ट इज डिफ्रेक्टिंग एक्सेप्ट वन ऑन द राइट हैंड साइड टॉप, और वही पार्ट दूसरे टोपोग्राफ में दिखाई देता है। इस वजह से इसकी बड़ी इज्जत है, बहुत सारे लोग इसको यूज करते हैं। वेरी रिसेंटली ऑल्सो वी हैड टू यूज, और मैं कुछ छोड़ देता। अच्छा, अब जो एक मैं लास्ट में कहना चाह रहा था कि आप डिफ्रैक्शन ही नहीं, रिफ्लेक्शन से भी बहुत इंपॉर्टेंट नॉलेज ले सकते हैं। अभी हम डिफ्रैक्ट करा रहे हैं, जो बीम निकलता है उसमें स्कैटर्ड बीम इंटरफियर करते हैं, डिफ्रैक्ट करते हैं, तब वो आता है। लेकिन अब जो एक बड़ी चीज है जो नोन है, साइंस वाइज थी पता, पर इसको समझना, इसको यूज करना इतना कभी हुआ नहीं था। अब यह है कि मैं पूछूं कि भाई कोई भी सॉलिड ले लें, उसका रिफ्रैक्टिव इंडेक्स कितना होगा, तो एक्सरे पे एक नई चीज जो है, शायद आप सब लोग जानते होंगे, पर मेरे ख्याल में नहीं भी जानते हो। एट एक्सरे फ्रीक्वेंसी जो रिफ्रैक्टिव इंडेक्स है वो यूनिटी से थोड़ा सा कम है, पार्ट पर बिलियन। वो यूनिटी से बढ़ के नहीं है। नॉर्मली तो हम कहते हैं भाई जब लाइट डालते हो तो 1.455 ये सब होता है, इसमें 1 से कम होगा। और जो जो उसका डिफरेंस है यूनिटी से, वो उसके स्ट्रक्चर फैक्टर, उसमें कितनी डेंसिटी ऑफ इलेक्ट्रॉन है उस पर डिपेंड है। तो हमारे पास एक ऐसा टूल है कि आप रिफ्लेक्शन से उसके इंफॉर्मेशन निकाल सकते हैं। और वो एक चीज और बहुत बढ़िया है कि जैसे टोटल इंटरनल रिफ्लेक्शन होता है, यहाँ टोटल एक्सटर्नल रिफ्लेक्शन होगा, स्पेकुलर रिफ्लेक्शन है, और उससे आप उसकी वैल्यू निकाल सकते हैं। स्ट्रक्चर फैक्टर बहुत डिटेल भी कर सकते हैं, वो आप लोग इसमें करते हैं नहीं, पर अब ये मैं लिस्ट कर रहा हूँ। ये जो रिफ्रैक्टिव इंडेक्स की वैल्यू एक्सरेज पे है, एक्सरे फ्रीक्वेंसी पे है, वो 5वें 6ठे प्लेस पे जाकर डिफरेंस आता है, पार्ट पर मिलियन में डिफरेंस है, और इसको आप एंगल में बदल सकते हैं। तो हम लोगों ने इसको नया एक्सपेरिमेंट करके दिखाया। जब आप ये एक सिंगल क्रिस्टल से देखते हैं तो ये जो स्ट्रक्चर आता है ये शो करता है कि वो लेयर टॉप पे कैसी है। नॉट ओनली दैट, you can make pictures, and in this picture you see many lines, and each of them have a specific refractive index, therefore a composition, and you can determine that composition. ये अभी जो मोस्ट एक्साइटिंग अभी पार्ट है, एक 10 नैनोमीटर थिकनेस की लाइट, उसका हम लोग डायरेक्टली उसका भी इमेज ले सकते हैं। इसका फिर हम लोगों ने उसकी वैल्यू निकाली, कंपोजिशन और वो सब है। अब मैं थोड़ा सा आता हूँ कि अब अगर आप एक प्राइवेट यूनिवर्सिटी जिसमें पैसा ना हो, तो वहाँ हम लोगों ने एक इंजीनियरिंग किचन सेट की है। ये दिनेश सिंह जी का आइडिया था, चांसलर। तो उस किचन में पहले हमने कहा कि हम एक नया क्रिस्टल ग्रोथ सिस्टम बनाएंगे, पर कन्वेंशनल मेथड नहीं यूज करें। फर्नेस मैंने बनाई और वो भी अनकन्वेंशनल है। इस फर्नेस में वन ऑफ द थिंग्स दैट इम्प्रेस्ड मी, इस रीजन में क्ले बहुत है, इसलिए इफ यू गो ऑन द रोड लॉट ऑफ पॉटर्स आर देयर। तो मैं पॉटर थे तो मैंने कहा यहाँ क्ले अच्छी होनी चाहिए, क्ले की क्वालिटी अच्छी होनी चाहिए। तो वी गॉट सम क्ले, ऑल्सो वी यूज क्ले एज ए इंसुलेटर। फिर हमने एक और इनोवेटिव, जब ये पेपर गया तो रेफरीज वर रियली शॉक्ड अबाउट इट, क्योंकि हमने इतना क्लोजली वाउंड फर्नेस बनाई कि टेम्परेचर यूनिफॉर्मिटी बहुत अच्छी होगी। अब हमारे पास पुलिंग नहीं थी, तो हमने इसको क्रिस्टल पुल्ड को एक वेट लगाया जो कि एक पानी में फ्लोट कर रहा है। इधर ये पानी का एक ट्रफ है जिसमें ये फ्लोट कर रहा है। अब मैं जरा सा इस टैप को खोलता हूँ तो ये नीचे जाएगा, वो ऊपर आए। तो इस करके वी कुड प्रोड्यूस हाई क्वालिटी क्रिस्टल। जब ये जर्नल में पहले छपा था तो रेफरी वाज शॉक। उसने कहा हम तो इतने पैसे पूछे, हजारों रुपए, इवन एनपीएल स्पेंड लॉट ऑफ मनी, बट इफ यू हैव द नॉलेज, इफ यू हैव ऑल्सो द स्किल टू एग्जीक्यूट, इतने यूनिफॉर्म डायमीटर का क्रिस्टल आम लैब में भी नहीं बनता। आप ध्यान से देखिए। फिर आजकल जो मैं इस वक्त कर रहा हूँ जोन रिफाइनिंग पे, ये इसका थोड़ा सा और इम्प्रूव्ड वर्जन है। मेरी समझ में ये बहुत आता है कि हमारे खासकर जो इंडस्ट्रियल सराउंडिंग है, जैसे गुड़गांव है, यहाँ वेस्ट मटेरियल बहुत है। कैन यू कन्वर्ट दिस वेस्ट इनटू वेल्थ? मैंने एक कोर्स लिया था इधर KRM में, तो उसका ये है कि इसको जोन रिफाइन कैसे करें। तो राइट नाउ वी हैव सेट अप ए जोन रिफाइनिंग सिस्टम। उसका मुझे फाइनल, हमने एल्यूमिनियम को जोन रिफाइन करके, बल्कि आई हैड टू यूज NPL फॉर सीइंग द इम्प्योरिटी चली गई कि नहीं चली गई, क्वांटिफाइंग द इम्प्योरिटी। और अब कॉपर का हम लोग कर रहे हैं। अब मैं थोड़ा सा ये ज़रूर करूँगा कि बहुत अच्छे लोगों से मेरा बहुत अच्छा संबंध रहा। उनमें एक प्रोफेसर फैदोर कुज़नेत्सोव है, अभी रिसेंटली उसका 90th बर्थडे था। उस पर रशियन जर्नल ऑफ कंप्यूटेशनल, नहीं, जर्नल ऑफ मटीरियल साइंस है, जो रशिया और स्विट्जरलैंड मिल के बनते। तो आई ऑल्सो कंट्रीब्यूटेड देयर। इन द एंड अपने गुरुजनों को नमस्कार करता हूँ। पहले प्रोफेसर वर्मा, लॉन्ग स्टैंडिंग, हम लोगों को वर्मा साहब बाद में कहते थे, कहना मुश्किल है, हाउ टू डिफाइन आवर रिलेशनशिप। एंड दिस इज द टाइम व्हेन आई रिटायर्ड फ्रॉम NPL फॉर्मली। और ये हमारे फील्ड के जो बड़े दिग्गज थे, उसमें एक FC फ्रैंक थे क्रिस्टल ग्रोथ के, तो इन्होंने कहा था नहीं मुझे फोटो दिखाओ। ये है कैपिट्सा, नोबेल लॉरिएट थे, वो भी उनकी एक चीज़ कमाल की थी, मैं कुछ कहूँ उन्होंने कहा नहीं फोटो लाओ। तो ये इनके, आई लर्न फ्रॉम देम कि आपने काम कैसे करना है। और फेदोर कुज़नेत्सोव और उसके ये ग्रुप है जो नोवोस्फीयर्स में, अभी ये पेपर एक पूरा वॉल्यूम छपा है उसकी ऑनर में। इसका इतना क्लोजनेस नहीं थी, ये कभी कभी NPL में वैसे ही आ जाएगा बगैर बताए। फिर उसे पता था मैं लंच में घर जाता हूँ, तो एक दिन मैं नहीं था, ही वेंट होम, मुझे घर जाना नहीं था, खाना, माई डॉटर वॉज देयर। उसने कहा तुमने खाना खाया है? उसने कहा नहीं। खाना खाओगे? उसने कहा यस इफ यू सर्व मी। तो बार बार मुझे वो रोज कहता था गुड़िया मेड लंच फॉर मी। he repeatedly mentioned that. So I asked गुड़िया recently, उसने कहा हाँ। मैंने पूछा भाई भूखे हो तो खाना खा लो? उसने कहा हाँ खाऊंगा। तो मैं आपको थोड़ा सा आज जनरल एक ब्रॉड व्यू दिया है कि हमें इनोवेशन सोसाइटल पर्पस के लिए करना चाहिए। मेजर डेवलपमेंट काफ़ी हुए हैं, इंक्लूडिंग जो अब नई डेफिनेशन है यूनिट्स ऑफ मेजरमेंट की है। डिवाइसेस और गैजेट्स का ज़माना है, हमें बेसिक कैरेक्टरिस्टिक्स का पता होना चाहिए। और कुछ मैंने कोशिश की कि आपको रिफ्लेक्शन और डिफ्रैक्शन की कुछ चीज़ें दिखाऊं। और इन द एंड आई ऑल्सो शोड यू, आपके पास पैसे ना हो तो आप ग्रोथ कैसे कर सकते हो। अब यही मैं एल्यूमिनियम को हम जोन रिफाइन कर चुके हैं, अभी कॉपर का इस वक्त लगा हुआ है, विद इन ए कपल ऑफ वीक्स वी विल फिनिश दैट आल्सो। ये मैंने सोचा, चूंकि अब इंडियन माइंड है, इसका बगैर शास्त्र के हमारे चलता नहीं। ये महाभारत के अनुशासन पर्व से है, तो ये उमा पार्वती से शिव भगवान ने पूछा कि भाई तुम मुझे स्त्री धर्म के बारे में कुछ एनलाइटन करो। ये उनका, अब उमा पार्वती ने क्या कहा कि मैं अकेली नहीं कर सकती, न च एक साध्यम पश्यामी विज्ञानम भुवि कस्यचित् व सागर गमस्थान, वो मान्य है। वो कह रही हैं, अब होली रिवर्स को, गंगा और इन सबको वो एड्रेस कर रही हैं। I do not see in this world or heaven any knowledge which anyone has created on his own without collaboration of others. I humbly seek your counsel. और हम तो हैं कहाँ पर, ये पार्वती जी पूछ रही है, महाभारत का है। ये मुझे वैसे बहुत पसंद है। विज्ञानम आनंदम ब्रह्म, उपनिषद से, कि जो विज्ञान में आपको आनंद है वो भगवान का साक्षात्कार है। ये वेद से है, पर वो आप पढ़ नहीं पा। अब मैं एंड में ये करना चाहता हूँ, ये एक बहुत बढ़िया श्लोक है। द हिस्ट्री ऑफ साइंस शोज दैट इवन ड्यूरिंग दैट फेज और ऑफ प्रोग्रेस in which she devotes herself to improving the accuracy of numerical measurements of quantities, which she has been long familiar with, preparing for the material for subjugation of new regions, which would have remained unknown if she had contended with the rough methods of early life. अगर आप improve नहीं करोगे तो नई कुछ भी दिखाई नहीं देगा। Thank you very much. This is what I wanted to share. Maybe I covered too broad a spectrum, but that's what I want to share.
Thank you so much, sir.
Thank you.
Sir, you have given such an enlightening lecture. The knowledge about the refraction, the broad ideas, your bright ideas and comforting guidance has a great positive impact on our audience. Sir, indeed, your words have inspired us a lot. Thank you so much.
Thank you.
I'm falling short of words, sir. Now, I would request Dr. Surjan Singh, the Vice President, Iapt RC-1, for proposing vote of thanks to our guest. Over to you, sir.
Okay. Very good morning to one and all present over here in the 10th Annual Convention RC-1 Delhi and Haryana. I, Surjan Singh, on behalf of entire team of Iapt RC-1 Delhi, a vote of thanks to all members who are present here. A very hearty vote of thanks to all esteemed guests, members, speakers for gracing the occasion and sparing your precious time with us. I extend my thanks to our chief guest, Professor Krishan Lal ji, Krishan Lal sir, former director, co-chair IAP for Sciences and past president of ASA, the Association of Academics Asia, for his valuable, enriching, thought-provoking address. Thank you very much, sir. Actually, sir, I have met working with CRPF, and I was working under Mr. Surya Prakash sir, and he was my guru, and who always meet such type of people, Dr. A.R. Verma sir, Dr. Krishan Lal sir, and Dr. actually our IAPT members. So I was introduced by him only in this organization. And since then, I'm working under this guidance and mentorship of valuable and others. Thank you very much, sir, for your valuable guidance. I thank Professor P.K. Ahluwalia, sir, President IAPT, Professor Y.K. Vijay, sir, Director, Center for Innovation in Science Teaching, Professor Rekha Ghorpade, General Secretary IPT, and joined us in. Must mention my deep sense of appreciation for participants and presenters in today's convention, and words of wisdom shall be very enriching and fruitful to all of us. I would like to take this opportunity to thanks to Professor V.P. Srivastava sir, Professor Sahajwani sir, Dr. O.P. Sharma sir for making this convention a great success. I would like to express my gratitude to Dr. Seema Vats, ma'am, President IAPT RC1, Dr. Yogesh Kumar sir, Secretary IAPT RC1, Dr. S.K. Singhal sir, Treasurer IAPT RC1, and all other executive members of RC1 for making an event like this cannot happen overnight. The wheels starts rolling weeks ago. Fortunate enough to be backed up by the eminent professors and educationists from all universities and schools, colleges across India. And some names are here with me. The Professor Ahluwalia sir, Professor V.P. Srivastava sir, Dr. O.P. Sharma sir, and many more are there who are backing us, who are guiding us, who are supporting us in all fields, how to organize this type of great events. And thank you for you people for your valuable guidance and timely support. At the last, I'd like to express my gratitude for distinguished faculty members of Delhi University and other universities, Delhi schools and schools from all other parts of the India, NCR and Anveshika to make this program a successful program. At the end, I would like to say the team efforts, and we all are working under the supervision of Dr. Seema Vats to our level best. And thank you very much. Thank you all. Regards to all. Thank you. Now over to you, Poonam ma'am.
The online tool on Innovation Hub is waiting for all of us. So I request Professor Y.K. Vijay, Sir, Director, Center for Innovation in Science Teaching, IIS deemed to be University, Jaipur, kindly innovate our participants and audience with the collection of his innovative experiment. Over to you, Vijay, sir.
Thank you. Thank you, Poonamji. I'd like to thank all the members and the team of IIPT RC2, Delhi and Chandigarh. Am I correct?
It's RC1, Delhi and
RC1,
Haryana.
Delhi and
Haryana.
Haryana. Correct. And when the invitation came, I said, this is the best opportunity to interact with dignitaries and share the experience and journey with all of you. I'm really honored to talk just after our great leader, Professor Kishan Lal. I learned quite a bit from my visit to NPL when I was with the University of Rajasthan, working with Professor Saraf, and probably you also visited us sometimes and have seen some of the laboratory instruments designed and developed by Professor Saraf. And I had that journey, and well, I appreciated 2-3 remarks from Professor Kishan Lal, that research is coming from the mind, not from the money. And even after his long journey in one of the institution, he is working with the crystal growth with innovative method of dragging the crystal out by floating water mechanism. It's a great, you see, that sort of innovation is needed in the young mind, okay, to share with the coming generation, because everybody wants to sit in the comfort zone and play with the mobile and do things in a virtual mode. Nothing can replace the hard work of individual. Okay, and that is what the lesson I'm getting from Professor Kishan Lal. Well, he was talking about the crystal structure. I can share, although it will come within the presentation also, I can share with the model. Okay, it looks like a same picture, scanning electron micrograph picture, but it's a toy. Believe me, it has got steel balls and showing you all the features which you see from the scanning electron microscope. Expensive toy. This doesn't cost more than 2,000 rupees. Okay, I can talk about the annealing, I can talk about the defects, dislocation, vacancies, and so on. So, well, the idea is how do we innovate and how do we share? So you have given me a wonderful platform. I can take you the tour, but in the online mode to have a tour, there may be difficulty of this internet. I had to go with the mobile. So what I did this morning, I make a small video clip, which I can share through my presentation. Okay, although I'm sitting in the same place, so I can take you around if the audience want, but you will get a glimpse what I'm talking about. And then I can show you, I'm representing the IAPT RC6 activity, and particularly I have connected myself with IAPT full-time. Okay, and the mission is to set up the innovation hub all over the country. And I started about 4 years back. First innovation was set up in one of the institutions here in Jaipur, and now 37th innovation hub will be coming soon in Maharashtra, Balasha. Okay, so this is one or two innovation hub I will show you. One, I'm really happy about the government school. They invited us to set up an innovation hub. It was a mission project of about 2-3 months. So they built up the laboratory right from the sketches. And once the lab was there, as per our requirement and dimension, then they invited us display these equipment. The way in Haryana this has been set up, it's a memorable for us. You know, we work together in a team. So I will show you a video clip of that. Okay, and maybe a few video of some of the experiments. Okay, which are fascinating, which I like to share. Okay, so my presentation will be, of course, within 1 hour, right? But I can cut short it whenever you like. So are you ready? Should I share my presentation?
Yes, sir, please.
Please, sir.
Okay, can you see
Yes, sir, it is loading.
the slides?
Slides are getting loaded.
Okay,
Yeah. Yes, sir. Kindly go to the full screen mode.
all right. So, well,
Perfectly visible.
I appreciate the theme shared by Professor Kishan Lal. The science is for everyone. Okay, we have to do it patiently. All right. So I enjoy this emoji. All right. And the theme play, enjoy, and learn, which I talk about in recent years. I dedicate to all this contribution in the centenary of quantum science, C.V. Raman, Meghna Shah, and S.N. Bose, because in physical world, they really talk about this minute world, quantum world. And in science teaching, we are telling our next generation about these atoms and interaction and energy transfer and so on. So what is our role, you know, as a teacher? So we have designed and developed models to teach that concept, okay, the quantum science. So I'll be talking about the Raman effect model, or the origin of light, okay, or the energy transfer. through the laboratory models, demonstrations. Okay, so this is a tour of Innovation Hub. This is CIST, is one of the private university where I'm sitting, and it's in Mansarovar, Jaipur. So this is installed in one of the school here. Okay, and my audience are school children. So they have a conventional lab, half of it, and the other part is given to me as a playground to teach fundamental sciences through the models. So I got a weighing machine made out of a tube of a car, which is filled with water, so that as children stand on it, the water rises up. I have a snack pendulum, rotation dynamics illustration, Maxwell top. In order to teach Bohr orbitals, I got this kind of model. In order to teach friction, I got air track model, okay, which comes from Professor Babullah Saraf's style of teaching. Okay, we have innovated and made it low cost so that it can go to everyone. So there is a blower which is blowing air in this tube, and this moving object has got magnets. Okay, all right. I got a water tray to show the reflection and the waves. I got floating magnets, dipole, to show the fundamental interaction, van der Waals force. A model on black hole to show the black hole dynamics, the spiral dynamics. So all these demonstrative models are working. Children can come and play with them. Okay, coupled oscillators made out of the strip oscillators, and we can talk about the energy transfer. They have got magnets on each one, so there is a interaction between these two. I got a graded length series of pendulum. When they start together, okay, they move in phase, but soon they develop the phase relationship, and you get a snack motion, rolling dynamics. Well, in Innovation Hub concept, we have in fact taken the theme from the Department of Science and Technology. All Indian scientists' contribution we have summarized and displayed, okay, on this Innovation Hub. Angular momentum conservation we show using the cycle wheel, mirrors, vacuum chamber. So all that makes you a vibrant place, you know. And this is what is the centenary year celebration program, where we are inspired by the IIPT leader, Professor D.P. Khandelwal. He stressed upon the quality education, physics through experiment, and 25 years back, he initiated a center called Center for Science Culture at Midnapur. And recently, when we thought of having this centenary year celebration, we have upgraded CSC, Center for Science Culture, to Innovation Hub. And we installed a 25th Innovation Hub at Midnapur last year. And throughout this year, the 36 we have already installed at Dungarpur, where in a school, Professor D.P. Khandelwal has studied, in fact. This is one of the Innovation Hub at Himachal. So they built the whole new laboratory for within the school premises with a grant from the government, about 10 lakhs. And the responsibility to set up an Innovation Hub inside all those equipment was given to us, IIPT RC-6. So all these working models are duplicated and installed there. And this is how it looks like. Any Innovation Hub outside Jaipur, okay, you should have a laboratory space around 800 to 1,000 square feet. And all these models, one of the vendor here he duplicates them and keeps them ready within a month. And we go there and install them. And it can be used regularly. We are responsible for repair and maintenance of all these, at least for a year, so that it can be used effectively. So the kind of models you have seen here in one of the innovation hub where I'm sitting, okay. So about 30 models there. This is a lift, manual lift, that is also mounted within the same. We have mounted an air cannon also, where the student can see when you hit a drum, how the air bullet comes out and hits the screen. We talked about the solar concentrator, flexible solar concentrator, and the periodic table, innovative periodic table, to talk about the different elements which are present and what is the use in daily life. Okay, so it becomes a lively place other than the conventional lab. We call it as an innovation hub. Well, for example, these models are reflecting some of the fundamental science. We say quantum world, quantum science, and we try to bring them in visible range. So let me show you, for example, atomic arrangement and atomic crystal, if you want to show. So we have got these balls, and with these balls, magnets are mounted. So there is a dipole interaction. Okay. So they are not touching each other. Okay. Am I audible to all of you? Audio ठीक है?
Yes,
Good.
sir. Perfect. Perfect.
Perfect. So यदि हम 6 बॉल रखेंगे तो पेंटागन सिमेट्री आ जाती है ऑटोमेटिकली, और एक हटा दो, स्टिल द पेंटागन सिमेट्री इज मेंटेन्ड. ओके, और एक और हटा देंगे, दे आर ऑल फ्लोटिंग ऑन सरफेस ऑफ वाटर, देन वी गेट अ क्यूबिक सिमेट्री. एंड एक और हटा दिया तो ट्रायंगुलर सिमेट्री बन जाएगी. They will reorganize. So that's how we say the atoms arrange themselves. So while playing, the children can learn. For example, this is a crystal structure, and I can talk about the vacancies and defects within the crystal, because these are the steel balls, okay, which are placed between 2 parallel sheets. Okay, so this is representing a monoatomic layer. All right, so we have a hexagon closed peg structure with vacancies, grain boundaries, dislocation lines. So all the vocabulary of solid state comes in your hand, okay, which you can share with students. You can have a different density of pegging also somewhere, okay, which is other than hexagon, like cubic. So this is a monoatomic. So if you have a binary, then the situation is different. It becomes something like this. It becomes a glassy, okay. There is no ordering in glassy structure. You don't see dislocation or vacancies. So here I got mixture of these balls, okay, 90% 1 mm ball and 10% 0.8 mm ball. They do not organize, you know, in a systematic way as this one has. Okay, if I want to show the van der Waals potential, I got this model. In this model, I have got a bar pendulum. Okay, normally it acts as due to gravity, but there is a magnet here and another magnet here, and these two polarity decide the repulsion or attraction. So if I play this, okay, so it never comes to the center. It comes in equilibrium away from the center. Okay, The gravity is bringing it at the center because it is suspended, but the magnetic interaction keeps it away. Okay. And if I have two magnets at the bottom, then the situation becomes like this. So initially this pendulum can swing anywhere, but as it comes close to one of the attractive potential of the magnet, so it can come to this one or to this one. Okay. And we can extend this to lattice potentials. Like this is how you have a single atom, two atom, and multiple atom. Okay, the bound states and the free electron concept. So these concepts can be taught through that demonstration. Okay. Like this is a bound electron to one of the atom. Okay, this is a free electron. But as the energy goes down, it will be localized to one of the atom. Okay, it's like bound electron. All right. If you talk about the single atom, so here the frequency increases. You can see if I take only a if you suspend these magnets, then the coupled oscillator you can talk about in terms of magnetic interaction, and the coupling is through field. Okay, and you can control the coupling strength by the separation of these threads. For example, Newton's cradle we talk about, where the collision is explained using such a device, mechanical device. Okay, you hit one ball, the other ball goes. Okay, if you hit two balls, then the two ball goes. If you hit three, here you normally listen the sound because the balls are in contact. But normally we say the atoms do not touch each other. Okay, they interact at a distance. So that concept can be bought using such a device. If you disturb one, the disturbance goes to the last one. Okay, and there is a delay involved. And back to first one. All right. So these concepts can be demonstrated, okay, through the laboratory models. For example, you want to teach the anharmonic oscillator. All right. So normally bar pendulum is a harmonic oscillator. But if the magnets are there, then you see, because of the magnet, there is an additional restoring force coming out. Due to that, it slows down and it reaches to the critical so that it cannot cross the barrier. So there is a potential barrier here. All right. And here, the restoring force comes out to be F is equal to minus kx plus additional term, which is a magnetic, due to magnetic interaction. Okay. In here, for example, there is a gravity is there and magnetic is there. So both are aiding each other. So for large amplitude, the magnetic effect is not there. But for a small amplitude, the magnetic effect dominates. And the frequency of vibration increases. So this is a magnetic oscillator, basically, dominant, not from the gravity. The effect of gravity is very small. one can have the oscillations resonance concept. One can have a coil and place a magnet, okay, which is floating, all right, and you can tune the frequency and get the resonance. And here, if I change the mass, okay, I get a different frequency. Right? So again, a spring mass oscillator, it becomes a field dependent, magnetic field dependent. Okay. Every time we don't talk of mechanical systems, but we talk of electromagnetic system. One can think of having a magnet at the center and talk about the bound state. And this is also one of the mode of vibration, resonance state. And even in here, the center remains fixed and the edge vibrates. Okay. This is fixed, this cannot vibrate, right? So this is a free end, which is vibrating. Well, in order to demonstrate the Raman phenomena, which says that there is an interaction of photon with atom. So we developed a model, mechanical model. This is a spring mass system, okay? And this is a bar pendulum, but the interaction is magnetic. So when this one moves, so it's like photon, okay? And this is an independent oscillator. Sometimes it interacts in phase or sometimes out of phase. And that shows the concept of Stokes or anti-Stokes line of Raman, how photon interacts with the moving electron. So we are trying to give most of these concepts through these model, okay? In order to show the Bohr orbital, okay, we have got a metallic strip which can be kept in the form of a circular ring, which is mounted on a speaker. And this speaker can be connected to a signal generator. And we can adjust the frequency, okay? So when you adjust the frequency, at certain frequencies, you get a condition. This is a node, antinode, node. So the thing is visible in a circular loop, and one can find out this kind of relationship. We call it as quantization of Bohr orbitals. It is interrupted. Is it okay?
Yes, sir, it's fine. Fantastic. I mean, we're enjoying. Yeah, please go ahead. Yeah.
Okay. This is a low frequency model of Bohr orbital. So this is the orbit, for example, and we are having a mechanical system.
Your screen sharing is not.
Huh?
We cannot see the screen, sir.
Oh, okay. I have to go back, probably. I have to go back to Zoom. Screen share. Is it there now?
Yes, sir. Yes.
Okay. I can go to full screen. So I got another 20 minutes. No problem.
Sir, you take your time.
Okay. Well, so I have got a strip oscillator. Is it visible now? Screen?
Yes, sir.
And this is a floating loop. Floating means on a bicycle rim, we have suspended about 24 pendulums and they are connected. Okay. And you are pumping energy at low frequency. And here the disturbance travels clockwise and anti-clockwise, and superposition is shown there. And you see that it reflects node and antinodes in this. at particular frequency. Okay. So even at low frequency, you can see the quantization of a circular loop. This has fine publication in American Journal of Physics. So most of these models, the academic contribution we have published in good journal. For example, alpha decay, if I like to show using this model. Okay. This is a moving track, and this is the oscillating potential of a nucleus. So here the alpha particle escapes. It doesn't interact. It interacts, imparts energy to the oscillating field. Now, if the energy is appropriate, then it may be trapped within the alpha particle. So it's all mechanical model depicting that phenomena, the capture and decapture. Okay. So every time it's slowing down, okay, at a particular energetic kinematics, the situation of trapping can be observed. Okay. It is still escapes. The video is continuing. It is still escapes. Now it is trapped and then escape. Okay. So such phenomena, the quantum tunneling, can be demonstrated on such mechanical models. Yeah. Well, we can show the molecular vibration also. For example, water molecule. The water molecule structure looks like this: oxygen and hydrogen. And again, this is mounted on a speaker. Okay. So when you excite at particular frequency, this is one of the mode of vibration. We call it as a torsional mode of vibration. At another frequency, the balls vibrate this way. Okay. This we call it as a stretching mode of vibration. Okay. So the bookish concepts are visible in this mechanical model. The same concepts can be demonstrated on methane molecule. We developed a spring mass system again. At low frequency, all these bonds are free to vibrate in this mode. We call it as a torsional mode. Okay. And at another frequency, all of them are vibrating up and down. Okay. That shows the stretching mode. So even if you have a composite system, okay, using such a signal generator and a speaker system, you mount a composite system, one can study the modes of vibration. And in molecular physics, these concepts are taught. For example, in order to teach the Rutherford scattering, again, we have a magnet, and this magnet can be released. And we can measure the scattering angle. So release it 2-3 times, analogous to the alpha particle interacting with the nucleus. Okay. So this is all mechanical model. We can vary the impact parameter also by placing this at different distance from the center and releasing it with different amplitude. We can vary the kinetic energy of alpha particle. So such concepts become visible. Well, when we talk about the gas discharge, okay, we have developed a very small vacuum chamber with rotary pump, okay, and 2 electrodes. And the high voltage at these 2 electrodes of the order of 700 to 800 volt is good enough. So when you evacuate it and apply DC, okay, after some time, 2-3 minutes, we generate a low pressure inside. Okay, and when the high voltage is there, okay, then there is a gas discharge. The gas inside gets ionized. And that gas discharge we can see in the form of plasma. Okay, the central wire is positively charged, okay, so that it collects the electron very quickly. The ion are unable to drift out, all right, so that you get a large density of positive ions around this central wire, and the outer ring is negative. Okay, the electrons are picked up very quickly. So such phenomena of plasma experiment can be done. Its all chamber is made out of the acrylic. High voltage supply is locally built using the transformer and a electronic regulator. Okay, so I mean, when we talk about the innovation hub, all these scientific models are low-cost version. They can be easily understood, the mechanism, the dimension, and run and maintain them. Okay, there is not much sophistication. For example, with the toy, we share the concept play, enjoy, and learn. So the toy can be mounted on a speaker, okay, and add these two balls as an ear. Okay, so you are having a human face like structure. When you see the vibration mode, this is how the vibrating mode look like at a certain frequency. But when you change the frequency, then you can have this sort of mode excited. This we call it as a twist torsional mode. Okay, and right now we say moods means he's saying no. All right, samajh mein aaya, nahi samajh mein aaya. Okay, and when you tune the frequency, again it says yes, ab samajh mein aaya. Okay, so the children are thrilled to see such toys, okay, which are scientifically controlled with the frequency. All right. Well, or yadi or frequency change kare, then you have a situation of a joy, you know, maja aaya. All right. So, well, these are symbolic, okay, of the scientific models we have. All right. There are many more, a big list of about 50 models we have designed and developed. Okay, all low cost. Maybe I can share with you. This is just a stand made of a syringe and an acrylic paperweight and a scale. Okay, if you mount one ring here, the another magnetic ring, it is in the attractive mode, but if I reverse it, it becomes a floating because of the repulsion. And I can add one more. So the two rings become floating. All right. The separation of these two can be measured on a scale and can correlate because the mass of each ring is same. Okay. But in the bottom one, there is a force double the rings. Okay, the weight is also acting on both of them. Okay, if you have one more, all right. So this is the separation gradient which is generated. Okay, the top one is floating, but this one is restricted. This has got a load of about 30 grams. All right, but this second one has a load of about 60 gram, 2 rings it has to support. Okay. And this one has got 90. The last one has got 120 gram force. Okay. And therefore the separation changes. All right. So such experiments, we try to develop the innovative experiment which can be taken to the laboratory. Okay. They can learn the science, the fundamental interaction. Okay. By playing. All right. There are no sophisticated measurement tool. So all concepts which I have shared with you, the theme is they should learn how to design and develop the experiment. Okay. For example, the electroscope we talk about. Okay. Gold leaf electroscope. They can make themselves. Okay. Using the commonly available material. And it works. These are aluminum foil. Okay. And only a bottle, empty bottle, you connect, you have to hang 2 aluminum foils and close it so that effect of air is not there, and just bring a ball, plastic ball. Okay. Bring it close to the wire and it jumps out. It jumps out. Okay. So you can show the electrostatic charge at almost 0 cost. Okay. Can get a concept of positive charge or negative charge. Just touch it so that whatever separation is there, it leaks out. So the idea is the student should learn, develop a scientific model, okay, how the models are made, and connect them with the scientific measurements, the basic scientific measurements, okay, make them quantitative. Okay, so this is the idea. And in fact, as sir told, learning science is a pleasure, you know. Okay. And everybody should have a scientific aptitude. That is what we want. And we wish that every school and colleges should have some place where they can learn the science in an altogether different way, their own way, their innovative way. Okay. Quickly, should I show you another one? These things are just around with me. Okay.
Sir, can you just blow up your screen, because what we are, yeah.
Okay,
so
okay. I should remove this presentation now.
Yes,
I think
yes.
this is the last.
If you are done with it, then you can remove it.
Okay. I can show one video from Banur Public School, Pilibhit.
Sure, sir, sure.
Okay. This is the innovation hub they inaugurated about 2 years back, 1 year back. Okay. And similar models were there. And many students enjoy that. So they are done professionally so that they can stay there. Okay. The electromagnetic induction, air track, solar concentrator, Lorentz oscillator, all these models, we just duplicate and bring them there. Okay. And they display it very nicely and use it with the children. The mechanical wave apparatus is there. So those models which you have seen, almost every SAT is available, okay, with them.
Sir, I have a little query regarding this. Like, if we're in our Delhi schools, if anybody wants to set up this innovation hub, so please,
Yes.
in the end, guide us. How can the school
Sure. Definitely.
At the end of the lecture, you can share, right?
This is a DPS school, Rutherford, Uttarakhand. Okay. So in winter, we were there and showed all these things. This is an air cannon experiment. Okay. This is how it is shown. This is a vortex formation experiment demonstrated. This is a roller coaster model, you know, the pendulums which they can roll. Again, atomic configuration and defects. Okay. So we have designed and developed them. All right. So one step ahead, they should look professional, decorative. Okay. So they can stay as a good setup everywhere. Okay. So when I show you this model, again, this professional version is available now. This is how we innovated. For example, how do you develop the breakdown? High voltage. Okay. So there is an ionization in air. Okay. Which takes place because of the high voltage. And if you change the distance, okay, there is no, because air cannot be break down because the voltage is not enough. So if you bring it close, if you bring it very close, that is spark. Okay. And this is standalone. It's a battery operated. Okay. And high voltage is there, which is generated. And again, these are the steel balls coming from the pelmet. Okay. So that's how we innovate and design the experiment so that it can go to most of the institutions. Well, the procedure is simple. They have to pay some money to IIPT RC6, and it cost about 2 lakh plus minus 20,000. Okay. And well, we take time, about 1 month's time to duplicate them, and we bring them and install. Okay. That's how it goes. So we already got 2 lakh from Ava Khandelwal. Okay. She is the granddaughter of Professor D.P. Khandelwal. So she has donated to IIPT, and we are preparing that and bring it to Balarsha in one of the institution which is from her family. Okay. So that will be the 37th innovation hub. So thank you for giving me this opportunity. I'm delighted to share our humble contribution to IIPT, and I wish that we come to Delhi and Haryana. Of course, we are already in Punjab. Batinda we have installed. Okay. And Barnala we installed. Patiala, it is under pipeline. Jalandhar we started. Okay. Jalandhar, there are 2 innovation hubs. So, well, it's going. Okay. So thank you. If I have any other questions somebody asks, I'm ready to answer.
Thank you, sir. Thank you so much for such a lovely virtual tour, full of innovation, full of enthusiasm, full of hard work, which is seen via this presentation and the experiments you have shown. I can see a lot of appreciation as well as queries in the chat box. Sir, if you permit me, may I ask some questions?
Sure.
Yeah, sir. First question is from Mr. Aditya Sagar. He want to ask why plasma stick to the electrode.
Okay. Well, the plasma has got positive and negative ion because air is neutral. Okay, nitrogen or oxygen, whatever is there in the environment. Okay, when you apply biasing, the DC potential across these two electrodes, okay, there is a positive electron and negative electron. So once field is set up, then ionization takes place. Okay, so the ionization means the electron from neutral atom comes out. So electron is light, it can move away very quickly, but the ion moves slowly. And therefore, you see the illumination across the positive electron, because the electron is picked up from there. Okay. You can change the terminals from outside, okay, and get a illumination outside. The central wire will be less illuminated.
Okay, sir. Sir, more question. There is a student from class 12.
Okay,
Yeah.
very nice.
And she's very enthusiastic. She want to know that how she can set up the model. She, as per the information, she knows everything, but she wants to set up. She want to make some models. So
Okay.
kindly guide her how she can go ahead.
Firstly, she should make a tour, like she has already participated here. She can visit one of the innovation hub and get various ideas and what fascinates her. Okay, then from inside she has to come out what is the interest, then she can continue. Okay, for example, the molecular structure I talked about, methane molecule, water molecule. If she wants to try out benzene, okay, work out that and study the resonance states of a benzene molecule. Okay, because this is what 12th class students are learning out of the book. Okay, but in order to realize it in the form of model, that is what is a project, creative project. Okay, so she has to worry about the dimension. She has to worry about the relative bond length or material what she can use. Okay, and then mount it on a speaker and then talk about the resonance states. Okay, we have demonstrated with plastic balls and the spring which are available in the market. These are the springs basically used in the automobile parts. Okay, but one can buy variety of springs and play. Now it depends upon what is the power of the speaker to excite different modes. Okay, so she should use some good signal generator and a powerful speaker and mount your model. Okay, there comes the parameters like the mass of each ball. Okay, so she should look for light masses so that the parameters are workable within that signal generator. Okay. I mean, first is the observation. You should observe around what interests you and what you can do. Then the available material, she has to plan that with which material, okay, what science, what technology she is interested in designing the project. Okay.
Yeah, thank you, sir.
Yeah, you are welcome to visit Jaipur if you are around here. And I'm normally available in school anytime between 10 to 1. You can visit.
Yes, sir. One more query of the same time. Please share the way how we can visit any nearby lab with students and what should be the criteria to establish the lab. I think you should, elaborate a little more about the establishment of such kind of innovation hub in Delhi and NCR.
Delhi, yeah. Well, the institution has to provide a house, the lab, empty lab with some tables so that we can bring these apparatus model and install it there. Okay. The cost of fabrication they have to share. So once the management agrees, okay, he can send money to IAPT RC6 and we do it within 1 month time. Okay. So that's the procedure. Okay, we right now we are not in the big business like somebody is multiplying and selling. Okay, it's on one by one correspondence. Okay, from the mouth publicity, basically. Okay.
Yes, sir. Sir, what is the approximate cost?
Approximate cost right now it is about 2 lakh, excluding transportation and the other things. Okay, depends upon where we are going, how we go. Okay, so roughly the budget 2 to 2.5 lakh one can plan out.
Okay, one more, sir, query. If somebody wants to show all these experiments in his or her lab, so is there any copyright issues?
No issue, no issue. It's all published academic work of IIPT. Videos of all these apparatus are available. Okay, and also the technical details. Okay, we can share. And if you want to duplicate, come here, bring your own material. It's permitted. Okay.
Okay, so I
But
request
if they want our services, that we should set it up. Okay, in the way we are doing, our vendor is doing. Okay, they have to pay some money.
Okay, so sir, I think participants had got their answer. Oh, Alu Alias sir want to say something. Please go ahead, sir.
Okay,
Sir,
namaskar.
Hi, namaskar. If I don't say something that will be not good on my part, I must congratulate Professor Vijay for doing it so passionately and dedicatedly. And we have been in touch with him for quite some time on behalf of IAPT also and on my individual behalf also. And we have made sure that this process of providing innovation hub becomes more smooth as far as purchasing procedure is concerned. Because, you know, sometimes colleges, schools, particularly in the government sector, they like to fulfill certain formalities before buying it. Private schools can do it, all right. But for government schools, it becomes a big issue. So what Professor Vijay recently has done is he has already registered Innovation Hub for sale on what is known as GEM. I think you can always go on the GEM and purchase it from there. So that is what will make it very good. I think the target of Innovation Hub should have been or should be this. Sir, a target as a president of IAPT, I am proposing that target also. The target is that every district of our country should have at least one innovation hub. And I think we have around 800 in districts in the country.
Yeah, let's take
Can
a
we
mission.
really think of reaching that target? I don't think it is very difficult. In the next, I think, a couple of years, we should be able to see that. And I think we will have very big celebration at the CDEC or what is that center which he has created there to celebrate that kind of a thing. The second, you know, suggestion which I want to give is the following. Sir, once again, a small suggestion. And that is that please start a channel. Let us make a innovation every day. And I think you have such a repository of ideas. Let us start really doing that. Maybe you can create that on the YouTube, or you can go on the Facebook every day, make it live for half an hour so that people may join. Maybe our IAPT Facebook page can be used for that purpose also. I think you deserve a big clap, and that is what it is. Thank you very much on behalf of IAPT as well.
Okay, thank you.
Well, thank you so much, sir.
Thank Seemaji for giving me this opportunity.
Sir,
because
thanks
we were
for
planning
sharing.
1 day or 2 day, So I think this is very convenient. Everybody is connected.
And I'm sure you will get so many offers from Delhi schools now
Thank
to
you.
set up the
Thank
innovation
you.
hub, because
Yes.
they're financially well off and they can manage.
They can manage.
Actually.
Yeah.
Yeah.
I'm looking forward to. Okay. Good.
And actually, Ahluwalia sir has solved our problem by giving the
Problem, yes.
target to Vijay
Yeah,
sir.
sure.
Set up one innovation hub in each RC.
अभी हमने पिछली मीटिंग में बोला था कि each RC should have at least. Okay. तो हम तो सीमा जी से कह रहे हैं कि आपके RC के काबू में लीजिए एक इनोवेशन हब. ठीक है ना? फिर
Sir,
वो कोऑर्डिनेट
definitely.
बन जाएगा.
Sir, we are
बनेगा, sir.
always ready, always ready. Need
Yeah.
support and blessings, but always ready.
Good.
Thank you, sir.
Now-
Thank you so much.
Thank you,
Okay.
sir. Thank you
Continue.
once again for such a nice activity, and hopefully we will have you in the offline mode very soon, and we
Sure,
will
sure.
have
Yeah.
the innovation hub in RC1 with your help and support.
Okay.
Thank you so much. Now we are delighted to have among us the eminent speaker, Professor P.K. Ahluwalia sir, the President IAPT. Today he is going to enlighten us on the topic use of classroom as research laboratory, physics education research. Over to you, Ahluwalia sir.
So thank you very much. And first of all, I must congratulate RC1 for continuing with the tradition of holding convention year after year after year. And I think that is what is desirable, because success of IAPT lies in continuity, not in, one-shot programs, but continuous firing of the guns all around, so that people may feel that physics is blooming in the country. I always treat RC1, Delhi and Haryana as a model RC. And I'm sure that under the leadership of Ma'am Seema Watts and very energetic colleagues and very senior mentors like Professor Sehjwani, we will really be going ahead in a great manner. I think we had today very good sessions, 2 sessions. One session by Professor Krishanlal sir, and another by Professor Y.K. Vijay. I think these 2 sessions have set the ball rolling for the success of this regional convention itself. Professor Krishanlal is a practicing scientist, and we could see that how a kitchen for engineering can be set up where there was no facility available. Now, this is how an innovative mind actually works. And he also talked about Professor Dinesh Singh, who brought many innovations in Delhi University. And I think NEP is now again talking about all these things. I hope now nobody will come and reverse what is being proposed in the National Education Policy 2020. That is again a very big challenge, because sometimes we make such decisions which are not guided by educational priorities, but are guided by some other reasons. So again, for a change, I'm not going to really make any formal presentation. मैं चाहता हूँ आपसे बात करूँ, आपके साथ खुल करके बातचीत हो. And the topic which I have chosen is something very close to my heart, and that is use of classroom as research laboratory, physics education research. Now, when I look at IAPT is a subject society. And subject society actually means that it has a lot of focus on physics, its learning, its teaching, its research. So everything actually moves around this subject only. And there are some areas which we are touching, but there are certain areas which are not being touched by us, on which we need to really start focusing more and more and more. And I think that physics education research is one area in which we should really start courses in the physics departments of the universities, and it should become a what you call harbinger of quality physics education at school, at undergraduate, and at PG level. It has all the means for doing that. Physics education research as a research area is not something which is very old as such when we attach physics with it. But we know that in education departments, we have been doing lots of research related to teaching and learning of what? Of say different subjects, but the persons involved may not be physics experts. And there was a time when people started thinking that if we want to do any kind of meaningful educational research in a subject, then it should be done not in isolation, rather it should be done by participation of physics teachers, learners, and researchers. So this is how, the beginning of physics education research started. My first interface of this particular area was with one of the lectures in Iapt itself. And that was in an annual convention which was held in Lucknow, where Professor Arvind Kumar of Homi Bhabha Center for Science Education actually gave a lecture on alternative conceptions of the students. That when we actually talk to a student, it is not necessary that every student has got same kind of a conception of a given concept. He or she is an individual and may think of a particular topic in a different way also. And where do we find the learners? We find a learner in a classroom. So classroom is where actually the action happens as far as education research is concerned. And the most precious resource for us there is a set of inquisitive minds who are sitting before us to learn things. And without them, I think we as teachers have got no existence. Only when student is in front of us, then only then we have some kind of a role to play. Otherwise, today people are talking about maybe we can remotely teach students. We can have, we can just get rid of students and maybe some other IT platforms can be used for that. But one of the lessons which we have learned from this COVID, period is this, that howsoever good tools you may have, but still you will require teachers as a, emotional link between the subject and the student. If this link is missing, students don't feel very comfortable. They feel like, because we are human beings, we always feel like talking to each other whenever we have some kind of a doubt. It may not be a big doubt from your point of view as a teacher, but it can be a very big doubt from the point of view of a learner. And that comes even when a learner, studies a lesson carefully or reads something again and again, or tries to do some experiment at home or something like that. So this precious set of inquisitive minds is one of the very important, resources which are available to us within the classroom itself. And this set of inquisitive minds also see a teacher in a very special way. They see teacher as all-in-one kind of a role. He is a mentor for a student. He is a source of knowledge for the student. He is a role model for the student. He is a partner in learning for the student. So there are many roles, which a teacher plays as far as a student is concerned. And we keep on, donning different hats at different times when we are actually dealing with our students. What has happened in the last 40 years of the development of this topic, or this kind of a research which I am talking about, a lot of ground has been covered. And in fact, now physics education research area is inspiring other subject research areas also. In fact, the second interface of my knowledge about PER was through a very interesting paper which I found on archive.org, arxiv.org. And the title of that paper was very interesting, and that really made me feel very proud of the fact that we are leaders in this particular way of reaching out to learners. And that was, can economics education researchers learn something from physics education researchers? What I will do is, I will post in the group or maybe I will give it to Ma'am Poonam to share it with you all, the link of this particular lecture also. It's a very, this particular paper also. It's a very interesting paper. So when I went through it, it was an eye-opener for me. And I was finding names of some of the leaders in physics education research in that particular paper. And this is how, we start getting into research, that you read some paper, you find some very interesting references in that, and you start proceeding ahead in a very systematic fashion. But there is one very discouraging block which is there in physics departments. I would like to also mention that. Suppose you want to choose this topic to do research, and maybe if you want to work for a thesis, people immediately, will say that, no, this is not physics. This is something which should be done in education departments. It's very, very difficult to convince people that people sitting in the education department have no knowledge of physics. If they have a knowledge, their knowledge is outdated. If you are sitting in the physics department, your knowledge is much better because you are a subject expert. And for really going into the depth of this kind of a learning which happens, say in physics, we require definitely a collaboration between physics departments and education departments. So we are not saying that what has been done in education departments is of no use. But I think we need to talk with them and bring those practices into the physics department when we want to talk about doing physics education research. So I think we need to really overcome this. Fortunately, after going through these kinds of papers, in Shimla, in Himachal Pradesh University, there was one of the candidates who wanted to do research in this particular area. And the reason was that she was already, at a stage where she felt that if she has to do research in core physics, she is completely out of touch. But she is very much into physics as far as subject at undergraduate level is concerned. So can I choose this kind of a topic to do some research? And I had to face the research degree committees and when we present, our synopsis, the questions from them that what are you doing? Are you doing physics or are you going to do education? And I had to tell them that there are physics journals for making publications of this research. And the biggest thing which was there was a journal being published by physical review people called Physical Review Physics Education Research itself. People were not aware of that physical review people would also be publishing this kind of a research journal. And for publishing that, there was a lot of effort which was made by the topmost physicists in the world. And one name which I would like to tell you is Professor Carl Wieman, who got a Nobel Prize for experimentally demonstrating Bose condensation. So he was the one who was at Colorado University having a full-scale interest in physics education research also. You will find that there is a lot of talk about virtual labs these days. And one of the virtual labs in Colorado is PHET lab, where lots of virtual experiments can be performed. And that is the creation of Carl Wieman itself. I came across one of his papers again, which was again having a very interesting title. And the title of that paper was, "Are we teaching science scientifically?" Now, this is a very thought-provoking title itself. And, sometimes we as teachers do not teach science scientifically. Rather, this is one of the biggest observations made by many people, that what we are doing in the light of, sitting in the competitive examinations, making people parrots to mug up things, and we are giving them such practice routines that they will be very good in answering those questions when they go for the examination. So really, can we come out of that kind of a rut and teach science scientifically or not? That is a big question which is there. Another very important thing which we should not forget is this, that when a student comes in front of us, such a student is not coming with a kind of a clean slate. He or she brings with him or her lot of things in the classroom. And you have to really make an effort that whatever they bring, which is like a knowledge of a novice, that needs to be converted into a knowledge of an expert. This is also very important. I'm sharing another paper also with you, which I would like you to read. Are we teaching physics as physicists actually learn physics? A very interesting paper, thought-provoking also, and that is what we need to really look at. So if I have to define what is physics education research, I would say that it deals with learning of physics by the learners and various possibilities around how we can make that learning a kind of a experience which prepares them to be experts in physics itself. If I ask myself also today that how did I learn, I think there were many foul starts in learning. We were just being introduced some kind of a topic, and in the middle of it itself, not even teaching it fully, we were left to do it all alone. Can we really make these things more interesting for the students to appreciate the subject itself? I'll give you some examples that why this kind of an approach is very, very important for following. I don't know whether you know these stories or not, but these are very interesting stories from the point of view of teachers as well as learners. One of the very famous textbook writers in USA at any point of time has been Robert Millikan. He was a very popular textbook author, and before Halliday Resnick came on the scene, his books were the most popular textbooks for the students at what we call as K-12 level or +2 level and +1 level itself. And there are lots of, controversies around how he arrived at the value of the charge on an electron itself. if you go to the history of the discovery of charge on the electron, you will find that he already started with this kind of a bias in his mind that the charge on the electron is quantized. And there were lots of, questions which was raised on way he looked at that data itself. That's a very, very crucial thing. And we know that Millikan's oil drop method is one of the very crucial experiments which is taught at different levels in physics classrooms. You may find it in +2 classroom. You may find it in undergraduate labs also. You may find it even in PG labs. And doing that experiment is not that easy. Its physics is very simple, but performing that experiment itself is an art, because you have to, make sure that you bring all your facilities to attention on various things which you have to handle. You have to produce a drop, keep it within the plates where you are applying the electric field. And for that, you have to manage the potential which you are applying. And then you would like to let it fall and record time also for that. So there are so many things, which happen around this experiment itself. And Millikan, wrote a beautiful book on electron itself. Its title is Electron. It's a beautiful book, I think, worth reading and seeing that how he was actually trying to do things. So there is a lot of history around that. There is one thing more which is worth appreciating, and that is that whenever we get data for any kind of an experiment, normally in our labs, students tend to feel that this is something which we are going to get, and this is a routine thing which will happen. Whereas once again, they never come to know that getting a data actually leads us to this kind of an exploration, that what this data is telling us and what that data actually means for us. I'll once again give you a very simple example. J.J. Thomson did an experiment. He could find that there is a new particle, which is a charged particle. And immediately after, discovering that kind of a thing with a lot of quantitative measurements with him, he proposed a model for the atom itself. And the model which was proposed was very simple, plum pudding model, which we call. And he said there is a positive uniform background, and in that electrons are sitting like plums. Now, this was good. This was a very good way of giving a new model based on one's data. And his own student, Rutherford, comes to him and tells him, look, I would like to check whether you are right or not. And he devised a very innovative experiment in which he fired alpha particles on a gold foil to see what happens to these positive charge particles when it meets a uniform positive background. And the results were startling. What he found was that most of the alpha particles are crossing, and very few particles are getting, turned back almost 180 degree. Complete turnabout, just what we call. And here was another situation in which he again tried to look at a very interesting theoretical calculation, and he proposed his new model, which he called as the nuclear model. So this kind of, bringing history into the learning of the physics also gives a very interesting perspective that how a physicist tries to learn new things. Sometimes he will be guided by a theory. Sometimes he will be guided by an experiment. Experimentalists like to corroborate theory. Theoretician will try to give some new results out of a given experiment, which he or she tries to explain with his or her theory. Now, these are very interesting things we sometimes miss as we try to move. Can you imagine that the same Millikan, when he looked at photoelectric effects explanation by Einstein, made a remark that it's what you call a reckless explanation for a beautiful phenomenon. Try to imagine that beautiful equation which Einstein gave, one liner, which is basically that how we should bring quantization into the picture and how this quantization of electromagnetic waves can be used to explain the emission of electrons from a metallic plate. But there were lots of thoughts. People look at something with different angles, and the same Millikan actually tried to say something about this. Now, if among physicists who are working at the top level, there are lots of things which they find very baffling to understand. Imagine a student who is encountering a knowledge for the first time in the classroom, how he or she must have been feeling. This is a $1 million question, which we must pose to ourselves and see whether it makes some sense or not. And that is what actually physics education research tries to address. And you will find that there are many areas in it on which you can focus. For example, when we were convinced that yes, physics education research has to be done in a physics department, the research degree committee, saw our presentation and they made us commit one thing, कि ये thesis publish होने के लिए आपको at least physical review वाले journal में एक paper publish करना पड़ेगा. They had put that condition. So we said, all right, if we will not publish that, we will not submit the thesis. So it was also again a kind of a challenge for us, but there were very good experts in that meeting also. One was from IIT Kanpur, who really encouraged us to go ahead with that. And we could do a very good piece of work on epistemology and on concept inventories. These were the two parts of that thesis itself. So I feel that this area needs to be looked at by very many people who are working very passionately in physics. And they can become very good physics education researchers also. And they can share their explorations of this kind of research with a very wide audience. Please keep in mind the goals of the National Education Policy 2020. There is a lot of talk of learning outcomes. And I can say for sure that there are lots of people sitting in this audience who have been part of creating learning outcomes, at least at undergraduate level, via a set of programs of the University Grants Commission itself. Now we need to really look at those. And as an IAPT, Indian Association of Physics Teacher, I would wish that we should scrutinize all those documents very carefully, whether they are really addressing things properly or not, and can we really make some good inputs into those kinds of documents. I have been really talking about this in my editorials in the IAPT bulletin also. And those areas which are there can be divided into a number of topics. For example, alternative conceptions is one area. That you say something, students understand something else itself. It's very crucial. Then second is on assessment. How do we assess that our student is learning or not? And for that, lots of assessment tools have been designed, whether a particular topic is being learned the way it is learned by experts or not. Then there is a lot of talk about behavioral aspects of the learners. If you ask somebody randomly, फिजिक्स कैसा सब्जेक्ट है, suddenly we will hear, oh, very difficult, ये तो बहुत मुश्किल सब्जेक्ट है. How it impacts the learning by making this statement itself, ये तो बहुत मुश्किल है. Half of the people you set aside who would like to come and learn physics. We have no way available, maybe now national education policy can provide us that way, where we can float a course in physics, not those who are going to do physics a major, but those who want to come and want to know physics and how it is actually impacting our society itself. Yesterday there was a declaration of a prize, breakthrough prize in physics, and we find that quantum computing is in the focus of that particular prize itself. This physics is once again coming into focus. We are talking about creating manpower for quantum computing itself. Who can take the lead? I think we as physics education researchers can come forward to create a curriculum for this kind of a course, which we can run in the physics departments. In the morning lecture, Professor Kishan Lal talked about machine learning, artificial intelligence. You will find that there are many now things which are happening in physics, which can be taught to our students to enhance their skills to face future. Is IAPT ready for that or not? Can we really think of such innovations in our various aspects? Then one area which is very interesting is the student characteristics. Active learning. There are, now what you call very, very big people who are participating very, very deeply into the ideas of active learning. Instructional material design. I would put Professor Y.K. Vijay in that area, that how he is creating this instructional material, which will be very interesting. I remember I went to Rajasthan University for doing a refresher course. And we were exposed to this lab, which is in a way a precursor to what we are calling today as Innovation Hub. And there was one experiment in which, they had put small steel balls to form a crystal stack, and then using, microwaves to see whether they can simulate the back deflection or not. That was there only. Now, this was very interesting to see that from where we are getting those ideas to see the things. And this is the most crucial way of looking at physics education research itself. I think lately I shared one very interesting book which has been published by IOP, UK, Institute of Physics UK. And that is on the relationship between virtual labs and offline labs. I will share that also with this group. That's a 300-page book, and see what kind of systematic research has been done in that to bring those ideas to what we call focus. Now, these are some of the areas on which we need to really become aware of. Lately, I was reading a very interesting paper by, once again, Carl Wieman. And I shared that also in IAPT group. And the title of that paper was How to Become a Successful Scientist. कई बार ना हम जब अपने बच्चों से बातचीत करते हैं और वो उनसे हम ये बात करते हैं कि आप साइंटिस्ट बन सकते हो, तो एक बड़ी अच्छी बात जो उसमें उभर के आती है कि कई बार हमको भी नहीं पता लगता कि हमको उनको कैसे बताएं कि how you can become a good scientist. And he looks at that in a very interesting fashion via how we should handle problem solving skills in the classroom. So problem solving is another very interesting area in which one can go and try to do something. Now, as I was preparing this lecture, I thought that I should take you to at least one screen from the internet, which will be of interest to us. So what I'll do is I'll share my screen and then I will open that page. Can you see the screen which I am sharing with you? Is it visible?
Yes, sir.
Okay. Now I have brought you to the best resource on the internet about physics education research. It is like a platform where all those questions which must be coming to your mind can be addressed. This is the home page of this. And in this page, they are very clearly talking about that education research is our focus. And try to see they are giving us information about what. What are the possible conferences which can be there? What is the community? Where are the PER jobs? Can you create wikis? What is the meaning of or some solo groups who are working? Are there any graduate students in physics education research or not? Then, you know, there is this curriculum, course packages, student activities, research instruments, pedagogy guides, browse all and suggest a material. They are even asking this. Can you suggest us a material on which people would like to really work? Now, also, you know, here is on dissertations. If you click it, you will find lots of dissertations have been listed here. And they are also seeking, can you suggest a dissertation topic to us or not? Or can you also suggest us a dissertation which has been done by the other people? And then there are, you know, publications which they are talking about. Reviews in physics education research, PRC proceedings, physics education research conferences, American Journal of Physics, and so on. Now, if you try to see here, you will find that they have divided physics education research into two fields. One is the basic research and other is the applied research. So when it comes to basic research, what you can do in that? It's achievements, alternative conceptions, assessment, behavior, cognition, communication, learning theory, problem solving, research design, and methodology. You can click and you go to lots of interesting things which are available to you as a resource here. Now, there is one thing which I would like to really underline, and that is that when we are talking about physics education research, this is being done at different places in the world. And many a times this research also is influenced by the local conditions and the history of learning of the subject itself. So if you do something, say in USA, if you do the same thing here in our conditions, you will find that the answers may not be the same. And we may find why such a difference is there. And that becomes a very interesting way of looking at various things. Then look at another set of societal issues, student characteristics, teacher characteristics, then applied research, active learning, careers, classroom management, curriculum development, informal education, instructional material design, learning environment, pedagogy, professional development, recruitment, school improvement, teacher preparation, technology. All these areas are there. And not only that, you can really search things by topics also. Astronomy, classical mechanics, electricity and magnetism, fluid mechanics, general physics, modern physics, other sciences, quantum physics, etc., etc. Now see, what is happening here? We can find that there is a very vast way of creating this kind of research within the classroom itself. So please be careful when we are talking about these areas and how to use these resources effectively. If any of the participants in this convention wants to get a big exposure for doing research in PER, I think you must explore this website. You will find under one website all the possibilities here. And what we have done, let me just take you to one more page, which is of Iapt website itself. You will find that here we have what we call our publications, then search. Let's go to the search and see here useful web links. Suppose you have not been able to really note down what I have been saying. For the last almost 10 years, we have provided these very useful web links here. And one of the web links which is available to us here is this physics education research. And you will find that for the website which I was showing to you is listed at the top here. Second is American Journal of Physics. And then that journal, which is Physical Review Special Topics, Physics Education Research, an online journal of physics education research. This is also listed here. Then Physics Science Research Center for Association of Physics Teachers. Physics Education. I think these are the 5 starting journals through which you can initiate work in physics education research very conveniently. Let me just give you a feel of this also, which is that the Journal of Physical Review itself. Yeah. Now see, an article which has appeared, and you will find it synchronizes very nicely with what we have been talking about. Let me go back to the article here. Conceptual challenges with the graphical representation of the propagation of a pulse in a string. See, very simple. Using the conceptual survey of electricity and magnetism to investigate progression in student understanding from introductory to advanced levels. What interesting topics, they are showing us. Let's have a look at one of the papers here itself. Now, these are all free open source journals. You can download and study them. It is available in HTML format. A PDF is also available. And let's look at the HTML format of this. So when we see this, you will find very interestingly, whole of the structure of the paper has been created. Theoretical framework, motivation and goal for the study. What were the research questions which were asked? What was the methodology which was adopted? What are the results? What are our summaries and conclusions? And all such things. And then this is being funded by whom? I think we need to really, as Iapt, need to go to funding agencies like NCERT, University Grants Commission, physics or science-based academic bodies like INSA or National Science Academy. If we go to these places and tell them that these are the areas in which we need to really bring in the component of research, particularly by the teachers who are in the field, please give them funds. This is also desirable. I remember that for our project itself in Shimla, when I was talking about, we got a fund of about 2 lakh rupees from University Grants Commission itself, where we actually established what we call clicker classroom for conducting that research with the students itself. Today, you don't need that much money also for starting a clicker classroom, because you can always convert your mobile also into a clicker instrument, and you can get feedback from the students in real time when they are being asked to answer some questions or some queries. So this is another very interesting thing. There are 2-3 names, which are very interesting. Have a look at this first paper itself. And look at it, when was it published? In 1992. And when they are actually talking about something, research as a guide for curriculum development, an example from introductory electricity. So when we are doing curriculum development, how research can help us to bring in what and where in our curriculum itself. So I think this is a very interesting area in which we really need to work. I think I am already 10 minutes beyond my time.
Yes.
But
So
I
please
would
kindly.
Yeah, I would just stop here and say my big thanks to RC-1 that they have given me an opportunity to come and talk to you. And whatever papers I have mentioned, I will share those with Ma'am Seema Watts so that those can reach to all the participants who are in this particular convention. I hope you enjoyed the deliberations. Thank you very, very much. And if there
Wonderful session, sir. Wonderful.
if there is any question, you are free to ask. Thank you.
Thank you so much, sir. Your session is totally enlightening the audience with such a knowledgeable lecture. It is indeed excellent and elaborate information about how to use a classroom as a research laboratory. And you have shown us so many generals, so many websites, and you are ready to share the documents with us. So it will definitely give us the information about the physics research education. Thank you, sir, for accepting our invitation and sparing your valuable time for sharing your knowledge about such a relevant topic. Now, I cannot see any queries in the chat box right now. Maybe participants will ask directly via the mail or maybe later on.
Sir, कुछ कहना चाह रही है. So please.
Only comment, sir.
Yes, sir.
It's wonderful to listen to you. Whatever we are doing is basically talking about the innovation, okay, in physics education. So innovation is totally connected with research, doing things in a different way so that we understand and share our next followers. So the apparatus you mentioned, the microwave diffraction. So I played with it. And in fact, during my master's program, when I came across, there was a question, even to see the diffraction pattern of sodium chloride crystal using X-ray, what you get interplanar distance and so on. Okay, so the basic question is whether you understand it or not. So microwave source was a 3 centimeter wavelength source, okay, about 10 gigahertz frequency, and we had to develop a crystal with 5 centimeter spacing. So the aluminum pellets were used to mount them equidistance on a thermocol sheet, and then we used to develop the layer. So initially it was the cubic structure we made, then BCC, FCC, so variety of crystals we designed ourselves, whatever we have been studying in the master's program, you know, from the Kittle's book, we translated in a about 30 centimeter by 30 centimeter matrix. Okay, 1 foot by 1 foot का क्रिस्टल बनाया थर्मोकोल का और उसमें ये पैलेट्स लगाई, ठीक है, और फिर देखते थे कि यस बीच में भी लगानी है बीसीसी स्ट्रक्चर के लिए, तो थर्मोकोल शीट 1 इंच की जगह आधा इंच की लाए, फिर उसमें एम्बेड की, and then we verified with the diffraction data, the in-between peaks. So it's a great learning experience. You know, even the students' lab, as you are mentioning, or the classroom where we are teaching. In fact, every year we get a new, fresh mind to learn these concepts. Okay, so we have to exploit them, we have to use them, or channelize them to do the innovative things. Okay, so thank you very much for your thought-provoking talk. In fact, I enjoyed in between. I was interacting with my colleagues here, but certainly it was wonderful. And the lot of literature which is available, okay, the resources, it's valuable information you already shared. Initially, I was thinking, where do I search? But immediately I got an answer that's available on your web page. Okay, these links. So, well, the initial guidance is also equally important as you are taking a leadership. Okay, and well, for the younger participants, okay, listening to experts for a short time, like Kishan Lalji was mentioning, कि हमने क्रिस्टल स्ट्रक्चर का मटेरियल साइंस में पढ़ा सिलिकॉन को फिर यूनिफॉर्मली ड्रैग करते हैं और जो बुक में मेंशन है वो मोटर है लो स्पीड मोटर बट हियर ही मेंशंस एक टब में पानी भरो एक फ्लोटिंग ऑब्जेक्ट रखो एडवुड सिस्टम लगाओ सो आई मीन दीज आर माइंड बबलिंग थिंग्स यू नो तो कहीं से तो सोच डेवलप हुई है इनिशियली ओके and it has to be practiced, you know. If many people started using this, okay, the concepts, we are successful, okay, the purpose is. So thank you, Simaji, for giving us an opportunity and interacting.
Thank you, sir. You have given me another topic for your talk. Now, next time you will be giving us insights on this X-ray diffraction and all. Thank you, Ahluwalia, sir. Thank you.
Thank you, sir. Now, I request Rekha ma'am to say a few words.
Yeah. Thank you, Poonam madam. Thank you. Actually, it is my request to Poonam madam and she has sanctioned that request. I'll just take 2 minutes only. Being a student of Professor Arvind Kumar and Professor H.C. Pradhan, I could not control myself to, add this particular session on physics education research. Professor Ahluwalia, sir, thank you very much for giving a wonderful talk on this particular topic, which is not much paid attention by the teachers itself. You have brought out a very important idea of teaching science in a scientific way. I think it's a very, very important concept. And about the physics education research, I would just restate a statement by my Professor Arvind Kumar. When the physics education research was very new in India, when he used to guide us in certain concepts, he used to tell gatherings of people, whoever was coming to him for asking for physics education research, he said, never look at physics education research as an alternative to physics research or the last option to the doing research, because it was thought that whenever people never used to get opportunity or admission to the mainstreams of physics, they would say, let us try physics education research. So he just cautioned people that not to look at the physics education research as the last alternative, but it should be given a priority, and it is very important. And I have learned and I'm practicing a lot of things which they have inculcated in me, that is alternative concepts, problem solving, other areas which just Professor Ahluwalia talked, and I'm fortunate to have such guides and mentors in my life. Lastly, just my experience that those who are the autonomous colleges or the universities are involved in the syllabus framing, involved at least one person from physics education research. It gives you a very good direction to your syllabus, and that is what I have done when I was a head and my college became the autonomous. I have involved one person from Homi Baba Center for Science Education, and it gives you a really different angle in learning physics also. And I'm sure under the guidance of Professor Ahluwalia, the IAPT will take up more such programs under this PER, and we will get more information. Teachers will be really equipped with a lot of education tools and so on. Thank you very much, everyone. Thank you, RC-1. It's a wonderful convention. I've been enjoying. Though I said that I will attend only few sessions, but then I'm tempted to, attend throughout. Thanks a lot. Thank you very much. Thank you, Seema Madam, Yogesh Kumar, Poonam Madam, and thank you, Professor Ahluwalia, once again for bringing this topic as your topic for the talk today. Thank you.
Mr. Sehjwani was asking something. He was raising his hand. Sir?
Yes, sir. Yeah. Thank you so much, ma'am. Thank you,
Thank you.
Ahluwalia sir, for giving insights on the physics education research. Thank you, Vijay sir. Yes, sir. Sejwani sir, you are saying something?
Yes, I would like to say a few words.
Sure, sir.
मैंने आलूवालिया साहब को बहुत बहुत धन्यवाद दूंगा। इतना अच्छा लेक्चर मैंने बहुत सालों के बाद सुना है। आपने छोटी छोटी चीजों को इस तरीके से एक्सप्लेन किया, मिलीकान्स एक्सपेरिमेंट को, फैक्ट के बारे में आपने नॉलेज दी, और आप आज भी बहुत सारे पेपर्स पढ़ रहे हैं। ये मेरे लिए हैरानी की बात है एक्चुअली कि आजकल लोग पेपर्स तो क्या कुछ भी पढ़ने के लिए तैयार नहीं होते हैं। मिलीकान्स के एक्सपेरिमेंट के बारे में बताया, how much expertise it needs to perform this experiment. Principle is very simple, but then performing the experiment is a very, very difficult job. मैं जब भी अपने स्टूडेंट्स को बताया करता था इस एक्सपेरिमेंट के बारे में, तो मैं बहुत ही ज़्यादा पर्टिकुलर हूँ और पर्टिकुलर था, और उनको बताया करता था कि कितनी एक्सपर्टाइज चाहिए इस एक्सपेरिमेंट को परफॉर्म करने के लिए। फिर आपने कहा कि आर वी टीचिंग फिजिक्स as a physicist? Very good question. Actually, we are not teaching physics as a physicist. Are we teaching science as a scientist? The answer is, at the moment, we are not teaching science as a scientist. We have to do something. और आपके आइडियाज के साथ अगर हम काम करेंगे, हमारी सारी टीचिंग फैकल्टी काम करेगी, तो मेरे ख्याल में वो दिन दूर नहीं कि हम इस इंडिया को एजुकेशन का फर्स्ट हैब सुनेंगे। लोग यहाँ से अमेरिका जाने की बजाय अमेरिका से यहाँ आया करेंगे, जैसा कि पहले जमाने में हुआ करता था। ये है एजुकेशन हब था। और आलूवाले साहब, मैं आपका बहुत बहुत धन्यवाद करता हूँ कि आपने इतना अच्छा लेक्चर दिया। मेरे लिए मोटिवेशन है। और मैं भी आपने जितने भी चीजें सजेस्ट की हैं, जितने वेबसाइट सजेस्ट किए हैं, जितने लिंक सजेस्ट किए हैं, उनको पढ़ूंगा तो जरूर, क्योंकि अब मेरे पास इस उम्र में एक ही चीज है, वो पढ़ना, लिखना, कुछ काम करना, और वो मैं करता रहूंगा जब तक मेरी आखिरी सांस है। थैंक यू वेरी मच फॉर मोटिवेटिंग मी। थैंक यू वेरी मच सर।
Thank you, sir. Yes, ma'am.
Thank you so much. Thank you so much, everyone. Sejwani sir, Ahluwalia sir, Rekha ma'am, Vijay sir. Now we have our paper presenters with us. They are waiting from so long. So without further delay, I would like to invite Dr. Amit Kumar, Associate Professor, Bhaskaracharya College of Applied Sciences, University of Delhi. He is going to speak on the topic, a tool for explaining Lissajous patterns based on Scilab. Amit sir, over to you.
Afternoon all. Let me first present my screen. Is it visible? This might confirm.
No, sir, your slides are not visible.
Just a minute.
Yeah.
Just share your screen once.
Actually, I'm far away from my laptop. I have to rush to somewhere. So
We can shift over the presentation of yours. Can we do it later on?
Yeah,
There's
you
a
can
problem.
do it later on if
okay.
not comfortable now.
Yeah.
Okay.
Poonam,
Okay.
call upon the next participant.
Yes,
What you
ma'am.
can do is maybe ask his presentation to be emailed to you so that you can show
Yes,
it.
sir. Yes, sir.
Yes, sir.
Yes, sir. Sure, sir. So our next presenter is Professor Punita Verma, Professor Kalandi College, University of Delhi. She is going to speak on the topic Joy of Learning Physics with Virtual Tools. Over to you, ma'am. Ma'am, you are on mute. Ma'am, try now.
Can I now present? Actually, I was sharing it wrong.
Amit sir, I have already announced the second speaker. Can you please?
I have no problem. I can wait. It's not a problem.
Okay,
It's not a problem.
Fine. We can go ahead with Amit. Yes, you can.
Okay, okay.
No, no problem.
I think now it is visible.
So your slides are still not visible.
No, it is taking a time to upload to the Zoom. Just a minute.
So share it once again.
Okay. Now I think now it is
Yes, sir.
visible.
Yes, sir. Perfectly visible.
Thank you.
Please go ahead.
Okay. So my name is Dr. Amit Kumar. I'm a teacher in Department of Electronics, Bhaskacharya College of Life Sciences, and I'm teaching there since 2011. And the problem of explaining the Sargis pattern I encountered during my early stages of teaching. So what we used to do, we have an experiment in the first year when the students was coming from the school and they were just joining us, and we were asked to explain them the Sargis in the first year itself, in the first year. So what I did was basically, what is the Sargis figure? So if we see the Sargis figure is any number of characteristic loops of curved figures traced out by a point undergoing two independent simple harmonic motions at the right angles with the frequencies in simple ratio. In simple ratio, we mean that it is being means in integer ratio. So these are the stable patterns which are made when the two simple harmonic motions are projected perpendicular to each other. So the Sargis figure have been known for more than 100 years, but they are studied in past 30 years more especially, and their evolution, shape, and periodicity, simplicity has been studied and formulated today. So the concept of the Sargis figure is presented in many engineering and scientific branches through the primer of primary undergraduate students. And the concept is simple, but it requires a lot of discussion in the classroom teaching. And sometimes basics of it requires endless graphical patterns and occasionally even that field. So this is how we used to explain the Sargis figure in the classical conventional classroom teaching, where we draw the two sinusoid and then we project it to two perpendicular directions, and we used to explain how the projection is made on a square. So something like that. But this discussion was taking so much long time. So I shifted to computational skills. I use the computational skills to explain the thing. And I have found that the students coming through the graduation now these days are more equipped with the computational skills rather than means learning and then computing. They find easier to compute first and then learn. That means that computing while before learning makes them more suitable understanding of the concept. So I used to explain them the Visage's figure by using Scilab console. Scilab is basically an open software which is widely used in the educational institutes worldwide. And it is primarily used for the electrical signals, but it can be applied to any other branch of where the simple harmonic motion is there. So the thought of explaining the Visage's figure through a plotting was not new. It was suggested by Putarsa, and he used the spreadsheet to explain it. But I found that using the spreadsheet is much more time consuming and much more, it requires hardware skills also, the computers also. So we used, I shifted to the Scilab console. So of course, we explained the experimental setup for getting the Visage's pattern on our CRO, where we apply two sinusoids by two frequency generators to a CRO screen and then put it to XY floater. The same thing can be done when the Scilab console. So what we do is we define a vector t from 0 to 2 pi, and then for the first cycle, and then we take two sinusoids V1 and V2, and then we plot it V1 and V2 independent to each other, and then we plot it to two perpendicular directions. So this is the pattern that we get. Two sinusoids of equal frequency, they of course produce a straight line like this with the 45 angle slope. So if the slope is changed to 90 degrees, then it becomes a circle, and then 180 degrees, then again its slope changes like this, and so on. So 3 pi by 2, you will get this. Means you can change. We can take the V1 as it is, and we can change V2 according to our desire. So phase difference of 3 pi by 2 can be taken to a circle of unit radius, and pi by 4 like this, 3 pi by 4 like this, 5 pi by 4 like this, 7 pi by 4, and the concept of having two similar patterns on two different phases should be explained by short plotting of the curve. For example, if we see that we have plotted two cases where the phase difference is 90 degrees and 270 degrees. In both the cases, the Visage's pattern is unit circle. But difference lies on the fact that the plotting in the first case was anti-clockwise, that is positive direction, and the clockwise in the negative direction in the second. So this may be appreciated by plotting a breach or break Visage's pattern for t to be varying from 0 to 6 rather than 2 pi. So this can be illustrated. This break the Visage's pattern explains. The first one is clockwise, another one is anti-clockwise. So we can get we can explain that the plotting means the pattern is same, it looks same, but the projection point actually executes two different directions. In one case it is clockwise, and in other case it is anti-clockwise. And also there is a good advantage of using Scilab console because it can be accessed to cloud scilab.in. So we can use these patterns on by using this Scilab cloud. So if can go to test. I'm not. I mean, this is the pattern which I made on a simple mobile phone. Generally, graduate students have the mobile phone with them. I used to say that please use your mobile phone and just plot it. And they used to plot it there and then by using simple instructions set like this. Right now, it is not an active link is not active. Otherwise, I could have plotted it there also. So let me skip that. So these are the patterns that can be made on a on a mobile phone itself, and we can explain the Lissajous pattern there and then in a class. So we can draw the conclusion that the plotting tools such as Scilab console can assist and alleviate the initial pedagogical problem that we encounter in explaining the Lissajous pattern. The chalk and talk learning process method evidently is an efficient way to communicate the concept of Lissajous pattern, but it takes longer time. So tool like this has proven to be more useful in introducing Lissajous pattern to the teacher who find drawing the tedious figures and difficult and time consuming. One disclaimer that the pattern, the figures and the fact which I have shared here have been published in this Iapt bulletin earlier this year. These are some of the references that I've studied for this study. With that, I will conclude. Hello.
You are not audible, Amit. Can you be a little bit louder?
Ma'am, I said I have just concluded. I think.
Okay, fine.
Okay, thank you, Dr. Amit. No, I can't see any questions in the chat box. If participants will have, maybe they can directly mail you. Thank you for your presentation. Now, I request once again Professor Punita Verma, Professor Kalandi College, University of Delhi, to kindly speak on the topic, Joy of Learning Physics with Virtual Tools. Over to you, ma'am.
Am I audible?
Yes, ma'am, you are.
Good afternoon, everyone. And I think after the wonderful talks that we have just had from the morning, there is hardly something that we can add on to it. I'm really grateful to professors who have spoken before me. And I think they have enlightened the entire audience about the real joy of learning physics. So I would now share my screen. Here. Is my screen visible?
Yes, ma'am. Kindly go to the presentation mode.
And I go to the presentation mode. Is it clear?
Yes, ma'am.
Okay, so I speak about the joy of learning physics with virtual tools. For me personally, physics is an enjoyable experience, and therefore I cannot think of anything except the joy that we really experience while teaching and while learning along with the students. So we all know teaching is a never-ending challenge. There is a Maxwell distribution of understanding levels of students. There is a Maxwell distribution of language proficiency of students. And there is a finite probability of having disinterested students, a finite probability of having focused elsewhere students, and so on. However, all these Maxwell distributions that we experience, or which all teachers experience in their class, it becomes a source of inspiration to explore experiential learning and the usage of virtual tools to make their understanding better and to make them really enjoy physics the way we have done all over the years. Regarding experiential learning, I'm not showing details here for the paucity of time and would focus mostly on the virtual tools. But I would like to add that even during the COVID time and even otherwise, the experiential learning has shown me a real remarkable change in the performance of the students. For example, I always quote some of the examples of having given a task to the students. Can you really explain photoelectric effect by using a model? And there came up a girl who made a complete model of photoelectric effect using paper balls and so on. And in the end, when I took feedback from her, she said that I did not understand the photoelectric effect so much by reading the books, although it is there in class 12 also. But making those models and making a video of explanation really helped me understand. This is just one example. There was another student who used snakes and ladders to explain a particular concept of atomic electrons transition. So according to her, if she used the Ludo with snakes and ladders, then if she reached a position of a ladder, then it was the time when the electron will make a transition to a higher level. And then if she uses a snake, then the electron comes back down to the lower level. It was something very bizarre for me. And it was really an interesting experience that students can really think so far and wide for understanding simple physical concepts. There are hundreds of examples of experiential learning. And I can say for sure that each student who has participated in making a model and then trying to explain that model herself with the help of a video of whatever quality it might be, it has enhanced their learning and understanding and more regarding the interest of the subject. So I would here focus on using virtual tools to enhance the understanding, and I would touch around 6 virtual tools which I have used along with the students to increase their understanding regarding the various aspects of physics. First, I will speak about SRIM, the stopping and range of ions in matter. The website from which it can be downloaded is shown. The second one, XCOM, which is photon cross sections, can be measured, can be calculated on a personal computer. And calculation of attenuation coefficient, a concept which is very difficult to understand to new graduate students. A software for that called XCOM and its website, and another software, Itacha, which is a code to predict the charge state distribution of multi-charged ions in solids. While we are teaching atomic physics and nuclear physics to students, especially in atomic physics, we require them to understand the concept of a charged ion, which is used various places. The accelerators, the particle accelerators are using charged ions, and then the charge state concept. The students get confused with the charge state concept that they've learned in chemistry. So here I found the usage of this code, which clarifies to them how a charge state of a particular ion, while it moves through a particular target, how it changes. Further, the virtual laboratory is known to most of the students, so I will touch upon it in a small way, which helped understand the students, to understand some parameters which cannot be done in a regular lab. Further, I speak about Magic Plot, a technical plotting, curve fitting, and data analysis application, which enhanced their understanding about several types of functions when they did their fitting themselves. And then lastly, the dig XY, that is digging out the XY parameters of a graph whose table is not given in a book. So I start quickly with SRIM, the stopping and range of ions in matter. It is a collection of software packages easily available, free to download, which calculate many features of the transport of ions in matter. It can calculate the stopping of the ions and their range in different targets. So you can use different ions, take any from the periodic table. You can use any targets, take any from the periodic table. And then you have 92 projectiles, that is ions, and 92 targets. And these many combinations, a class of BSc second year practices during the course of radiation safety, which happened to be the skill enhancement course in the now erstwhile CVCS course. It also allows you to learn about ion implantation, sputtering, and ion transmission, which is mostly used for post-graduation students. However, their inculcation with the introduction of SRIM makes them use this and understand what is the real meaning of stopping power, the range, the radiation depth, staggering, and various types of energy losses. So SRIM software, the website had been given earlier. It looks like this as we install it, and it is extremely simple as one can see it. One just has to write the ion name, and then automatically the software takes the mass and the atomic number and so on. You have to specify the energy on the right-hand side top corner, which asks for ion energy, how much lowest you want and how much highest you want, and you can specify your target. You can specify a target, you can also specify a compound target, and you can use the compound dictionary or you can use a single element. So if you want to understand this concept of stopping of ions and their energy in matter, all you have to do is run this particular simple software, which hardly takes a minute to do the calculations. So I've just shown you the output of this calculation here. The ion has been used as platinum and the mass is taken by itself, and the target is here used as carbon, and immediately comes out a complete output of the ion energy, dx, electronic, nuclear, projected range, longitudinal straddling, and lateral straddling. This is part of the course of radiation safety and of nuclear physics too, which is a core, which is a DSc paper in the present Delhi University syllabus. So just giving you an example, for example, this particular graph plotted by one of the students used platinum as an ion, incident upon carbon as a target. And these graphs that are plotted by the students, the whole class does the entire combination of 92 projectiles into 92 targets and plots these graphs to understand how the energy loss of various types, that is nuclear, electronic, and total, changes. And they draw inferences out of it. Here, I would like to play a small video.
Hello, everyone.
Is this audible?
And I have tried my hands on one of the most widely used tools, SRIM,
Yes, ma'am, it
stopping
is
and the range
audible.
of ions in matter. And as the name suggests, it is basically a group of programs that helps us to calculate the stopping and the range of ions in a matter using the quantum mechanical treatment in the ion atom collision. In the software, we use the moving atom as the ion and the target atom as the atom. And this tool has proven very much beneficial in my graduation while studying the radiation safety and nuclear physics. We calculated the electronic and nuclear energy losses in the ions while traversing to the targets of different thicknesses, penetration depth, their spread of energy, straggle along the way of the ion beam and the perpendicular to it as well. We have also calculated the electronic stopping power of the ion. Also helps us to study and analyze the various parameters such as the projectile velocity, reduced velocity, target orbital velocity, and adiabaticity parameters and asymmetry parameters as well. And its applications are not only limited to that only, but it also has applications in the semiconductor industries as well to estimate the ion range and dopant concentration profiles. So since I have done my post graduation in specialization in electronics, so while studying its curriculum, it really helped me understand the basic concepts of the ion implantation, ion transmission, and the sputtering. So yeah, it really helped me go a long way.
So I just wanted to show you this particular video of a student who did these softwares during graduation and has now completed post-graduation and is giving a feedback of whether it has helped her even in Masters of Electronics or not. Next, let's speak about XCOM, another software. It is a photon cross-section calculation software on a personal computer. We are generally talking about photon cross-sections or scattering in atomic and nuclear physics regularly to the students, and we try to make them understand the concept of total attenuation coefficient in any element, compound, or mixture. The energy can be varying from 1 kilo electron volt to 100 giga electron volt. So this particular simple software allows the student to really play with all the different types of combinations using different possibilities and combinations for different elements, compounds, and calculate all these things which I've highlighted in different colors. And the XCOM looks as simple as that. The website is noted above, and the screenshot of how the program can be run in 1 minute is shown. The output that comes out is, for example, given as here. So here the student has calculated for gold, and I would just now play a small video for the student who is presently working in Kalindi College BSc Physics Honors 3rd year and has just learned this last year itself.
Yes, myself Sakshi. Today I'm going to discuss about photon cross-section for. Good afternoon, teachers. Myself Sakshi. Today cross-section for photoelectric absorption, scattering, and pair production, as well as total attenuation coefficients for any element, compound, or mixture whose atomic number is less than 100 and its energy ranges from 1 kilo electron volt to 100 giga electron volt. Now, first of all, we will search for XCOM website on Google.
So the student learns.
We can choose our material, maybe element, compound, or mixture. We can also add our additional energies by hand. Now we can click on submit information. Now you can add details for your experiment, like atomic number, its energy ranges, and between which things you want our graph.
Now I'm selecting 21 scantium. You can add its atomic number 21 or its symbol SC. You can choose your graph options like total attenuation coefficient with coherent scattering, without coherent scattering, incoherent scattering, photoelectric absorption, pair production, nuclear field, electron field, etc. Now clicking on submit information. Then graph and other options is clearly visible and you can get your desired results. Proper legends will be given to the graph in the window shown here.
So that was another one example by which the students really understand a particular concept of nuclear and atomic physics and the general scattering. And now I speak about Itacha. Itacha is a code to predict the charge state distributions, as I mentioned, for multi-charged ions. When we are using an accelerator, we have ions of different charge states, and when they embed upon a solid or when they bombard upon a solid, then what is the exit charge state? This cannot be contemplated so easily by the minds of the students who are in graduation. And therefore, this code really helped them to understand how they can really calculate and play around with different projectiles, different charge states, and see how the cross sections vary. So the software looks as simple as this, and it hardly takes a minute to run. The moment you write down the projectile atomic number, and you can write down the incident charge state, the blue oval shows the incident charge state here as 26, and you can choose the different charge states of the projectile and the target of your light. So here we have a target of gold, that is 79, and the atomic number of 47. And then when we run it, we can run it for different charge states. For example, 26 I mentioned, you can run it again for various ones for 19, and one can obtain these graphs. So these graphs are also calculated by undergraduate students, and it helps them to understand that the cross section will vary according to the final charge state of the projectile. There are various kinds of graphs that can be drawn from this particular software, and it leads to an enhanced understanding because there are several parameters such as what if the incident ion energy changes, what if the target thickness changes, what if the initial charge state changes. In every case, the cross sections would vary, and one can easily calculate after playing with various combinations and can come to a conclusion regarding the enhanced understanding. So this is a video. I think it would be a little bit less audible.
I am Sejal Arora. I had the
Is it audible?
of working on a software called Itacha during my summer internship
No, ma'am.
graduation.
Yeah, so I will skip this because it has been shot at home and the video quality is not so good. I apologize for that. Usage of magic plot graphical software and enhancing understanding. This particular software, which is freely available for the students, allows them to do any kind of graph. So in fact, in my classes, all the students who are dealing with any of the labs that we are doing with physics, that is atomic and atomic physics or elements of modern physics, any particular experiment that they're performing in the physics lab, they are doing the regular hand graphs. That's one part. Additionally, they have to plot the entire data onto the magic plot, which is freely available, and then use the fitting of the magic plot to understand how their own fitting and the fitted curve provided by the magic plot is differing regarding the various polynomial coefficients. So here I have a video of a student who is explaining how you can even fit Gaussian profiles, Lorentzian profiles, let alone single straight lines or polynomials of a lower order.
Good morning, my name is Deepika Sharma and I have used this Multiplot software during my graduation work, which was under the Professor Punita Verma. And this Multiplot software is a software in which we can plot a huge amount of data very easily. We can simply import any data table from anywhere, just
He's
like
showing it.
click. We can fit it linearly, we can fit it Gaussian, we can fit it as a Lorentzian function, we can fit any polynomial function here so easily. We can also calculate the area under the curve here, area under the curve, and we can also do multiple peak fitting at the same time. We can clicking on the axis and we can save it as a template for any further use. So during my post graduation nuclear physics lab, it also helps me a lot in my data analyzation, and it's so Magiplot is a software which all of us need as a student because in my everyday plotting, and so I'm always at a beneficial side.
So I stop that and I move ahead. So with regarding this magic plot software, as I mentioned, each kind of data that is recorded in the physics laboratory in the college can be plotted in here, and then the student plays with it, does all kind of fitting, understands what is the meaning of least count fitting or least square fitting, he understands various curves, and then compares with the hand-drawn graphs and submits. This particular aspect of using a magic plot software for any kind of a graph enhances their understanding, such as the feedback of the students. So further, I speak about the virtual laboratory, which became quite well known to all the teachers around the country, and they use the virtual laboratory for performance of experiments. Here I mentioned the special experiment of photoelectric effect, because in our laboratory, the apparatus that is available in most of the colleges and other institutions, we cannot vary all the parameters that need to be varied in order to understand the photoelectric effect completely. And here I have a small video for student who explains how using the photoelectric effect from MHRD, she has been able to vary various parameters and draw around graphs which were about 3 times more in number than the usual laboratory.
And let us take an example of one experiment which I did, that is photoelectric actually in physical lab. And the difference between virtual lab and the physical lab is that it offers various things to explore. It offers various things to get it checked, to change the parameters.
One cannot
to try
change the
something
material
new. That
in
we
the
call
laboratory.
innovation, like taking two things and trying something new is innovation that it offers.
It
We
cannot
can
change the
actually
area
choose
of plate in
different
the
materials.
laboratory. But
We
here
can
one can
actually
change.
vary the area of plate, intensity, voltage applied, and wavelength of light to check what is its impact on the photoelectric current. That with magic plot, which is a very useful tool which helps me to stimulate, to write inferences from the graph and to understand it in a better way. I have plotted various graphs, like we have choose wavelength to change, we have choose the area of plate to change, we have choose intensity to get change, and check what its impact on photoelectric current or some other factor. This is very important to experiment new things by ourselves. It boosts our confidence and it gives us a strategy how we actually see the experiment to ourselves. Hello everyone.
So now I come to the last one, the dig XY. So most of the time when we are reading books, the standard ones, we are having data which is published there, graphs which are there, but they are not providing the value or the data from which those graphs are plotted. This dig XY actually digs the XY parameters from a published graph. So one can digitize the data from a scanned image from any book and use convenient copy-paste data transfer to spreadsheet programs like Excels and such as Excels, and then understand that if that particular graph is showing a particular trend, then what could be the parameters. This I experimented with my students of nuclear physics and atomic physics, and this DGXY, which is being shown, is one of the screenshots. As you can see, these curves are plotted in a book. The scanned image is taken, and nowadays the students are very good at it. This scanned image is then uploaded into dig XY, and it then locates each and every X and Y from that particular graph and makes a table out of it. Then from that table, one can plot further and then can assess that, okay, how are the parameters being changed and whether you can use it for further understanding of some phenomena. So I gave as a sample some graphs to the students, and they actually dug out all these values, which you can see on the right-hand side on the Excel sheet, which was very much required for understanding this particular graph of oxygen for a certain charge state bombarded upon uranium. Similarly, oxygen for a certain charge state bombarded upon bismuth. The author had not published any values, and we could actually take it out and then play with it for further understanding of our own values calculated by the students in their work. So here I have DGXY being...
While doing my internship under the guidance of Dr. Punita Verma, I also got acquainted to another tool, that is the DigXY. DigXY is a digitizer with a very simple interface, and it helps us to extract the data from any graph or plot. Like, it really has a simple interface. You just have to insert a graph and just you can digitize the data from it. It has a really simple interface which supports the logarithmic axis, linear axis, and helps us to use the scatter plots and the contour plots, and even you can extract the data from an image as well. So yeah, and then you can just have your digitized data in the spreadsheet. Theoretical concepts is
So that's it. And I now stop sharing my presentation. Thank you so much for having patience. Any questions?
Thank you, ma'am. Thank you for such a nice and wonderful presentation. There is one question. Can it predict neutron, proton, and alpha particle cross-section? The software you have shown?
No.
No.
No. It's photon cross sections, I said. Neutron, proton. For that, you have some other softwares. But you have other softwares with which you can simulate all that. One can even, for example, in nuclear physics, we teach them a lot about detectors. The detectors too can be simulated using some simulation softwares. That I'm right now experimenting. Softwares that I've shown here have been done not by one or two girls. I've shown one or two girls' video, but the whole class used to do everything. Therefore, and I took feedback from them. I told them that I'm doing an experiment with you. Do all this and tell me whether it helps better or not. And year after year, it is now around 4 years that these softwares are being done by the students. And the feedback is that yes, their understanding is increased and they understand the attenuation coefficients and so on better. If the person who is asking the question is interested, one can contact me personally and I can let you know whatever simulations are available for such cross sections.
I am Professor Sejwani.
Yeah, ma'am, Professor Sejwani has asked this question, so he will definitely contact you.
Sure, sir. I shall let you know to the best of my knowledge.
Oh, thank you very much. It was a nice presentation. Actually, I have worked on the nuclear reaction cross sections. And therefore, I wanted to know, is there any software which can predict the cross sections of the neutrons falling on any element? I have worked on from element number 1 to element number 110, and found out so many sections. So I was interested in if there is any say software which can predict the nuclear reaction cross sections of neutron falling on the nucleus, proton falling on the nucleus, and alpha particles falling on the nucleus. So I'll be thankful if you can search out some software and let me know about it. Thank you so much.
Sure, sir, to the best of my capability. Thank you so much. Any other question, Poonam?
No, ma'am. Thank you. Thank you so much. It's really a joyful learning physics with the virtual tool. And it is helpful for the graduate, undergraduate, even the research students. Thank you so much for the insightful lecture.
Thank you.
Yeah. And the next speaker is Professor Pushpa Bindal, Professor Kalandi College, University of Delhi. She's going to speak on aiding the offline teaching with online tools. Over to you, ma'am.
Thank you, Poonam. So, shall I share my screen?
Yes, ma'am, please.
While she shares, I can share that she shares all the joy of learning physics with me with various experiments that we do with our students. And she is with me in all these endeavors that we keep on trying with the students.
That's wonderful, ma'am.
Screen share? I can't make out. I think it is, yeah. Is it shared now?
No.
No, I have to do it.
I don't think she's able to share. It's not coming now.
Yeah, ma'am, her screen is also freeze right now. I think there is some network glitch.
Could be.
Meanwhile, ma'am is reconnecting again. Let's call our next speaker, Miss Monica Sidhwani, PGT Physics, Balbharti Public School, Rohini. She is going to speak about making innovative teaching methods a part of classroom. Over to you, Monica ma'am.
Thank you, Una ma'am. And a big namaskar to everyone present here. It's my first and maiden attempt in front of, such a august gathering. So I begin my journey. If we teach today's learners the way we taught yesterday, we rob them of tomorrow. Rightly said John Dewey. A lovely afternoon, everybody. This is Monica Sidhwani, PGT Physics, Balbharti Public School, Rohini, here to present a paper on this prestigious platform of eminent physicists. The title of my paper is Use of Online Tools, Teaching Methods, Low-Cost Experiments in Offline Teaching. Dear all, my article is in sync with United Nations goals set up for Sustainable Development Goals for a better and more sustainable future for all, set up in the year 2015. Out of these 17 SDGs, the fourth goal is set specifically to ensure inclusive and equitable quality education and promote lifelong learning opportunities for all by the year 2030. 21st century is highly connected with technological advancements, high mobility, and globalization. For this Generation Z, the information is voluminous, easily accessible, and free. We have to leverage this treasure of online knowledge, teaching learners to navigate the digital world competently and responsibly. For ensuring the holistic development of the learners, the focus has to shift from teacher-driven to student-driven pedagogy. That is pedagogy, with teacher being at the center stage, to andragogy, with teacher being a facilitator, and to heterogogy, with students taking their onus of learning, making way for a self-directed learning. Ladies and gentlemen, making innovative teaching methods a part of classroom thus forms the need of the hour. The classroom teaching must be such so as to provide an experiential, holistic, integrated, inquiry-driven, discovery-based, discussion-based, flexible, and joyful learning experience to the learners. That is, we must encourage questioning, provide opportunities to inquire, investigate, apply, create, present, hone metacognition, develop computational thinking, and allow for humor in the classroom. The learners benefit best from their joint efforts. In order to thus develop the fearless classrooms, it is imperative that learners are involved in all types of project-based activities, multidisciplinary activities, and interdisciplinary activities. Some of the best practices to incorporate the innovation in pedagogy and making classrooms engaging could be art-integrated learning, theater-integrated learning, flipped classroom, making a real-life connect, ICT-integrated learning, sports integration, storytelling pedagogy, and project-based learning in the classroom teaching. Let's now witness some examples of these pedagogies. Pedagogy based on humor. Addition of humor brings life to classroom. The learners can be introduced a concept using comic strips to begin a concept on a lighter note. Flipped classroom pedagogy. It's a blended learning technology where students watch online lectures, collaborate in online discussions, carry out research at home while engaging in concepts in the classroom under the guidance of a mentor. Here's an instance where the students of my class flipped my classroom to teach a topic of optics. Integrating visual arts in the teaching of physics not only adds colors to the learning process, but also makes the learning process more joyful. Some of the art-integrated activities could be role play, photography, PowerPoints, music and dance performances. Here is an instance where the accidental paintings made by paint pouring techniques not only created an excitement in my learners, but also made way for acquiring terms like density, viscosity, and various other concepts of fluid dynamics equally well. Integrating of performing arts like dance can ensure the learning of concepts like force, inertia, momentum with great ease. Here's an example of how students have integrated the moves of a ballet dancer with the learning of physics beautifully well. Let's see a small video of a student acting as ballerina and her counterpart explaining the physics behind her moves, highlighting the importance of concepts like center of gravity, balance, angular momentum, etc.
Whoa, look at this. Oh, let me measure this. Oh, hi. Don't get me wrong. I'm not a tailor. I'm a physics professor. You might be wondering what I'm doing here. Well, I am here to apprise you all on the amalgamation of physics and ballet. Yes, the dance form. Ballet is a sheer precision through years of tireless training. Dancers learn the fundamentals of physics in order to master this art. Okay, stop. I'm tired. Let's talk about my favorite part, physics. This position is called period. The act is spinning, the act is spinning on 1 foot, typically with 1 foot resting on the knee of supporting leg. During period, it is very important to find the center line of the body and the center of gravity. As balance plays the major role.
With no net external torque acting in it, the angular momentum is conserved with your arms, and L is equals to constant.
When the angular momentum is constant, with her arms and legs outwards, the moment of inertia increases, but the angular velocity decreases. When she pulls in her arms and legs, the moment of inertia decreases, but the angular velocity increases, which enables her to spin faster. I guess that will be it for you all today. Wait, I'll tell you the very basic physics principles we ballerinas use. Newton's third law of motion. Every action has an equal and opposite reaction. Push down to go up. The force you use to brush into the ground is the same amount of force that will propel you in the upward direction. So, focus on this movement and you'll brace out both your ballet fundamentals and physics principles. I believe now they know it all. Bye-bye. Oh, yes. And remember, my dear children, physics is the nucleus of all performing arts. This knowledge will help you in ways you can't think of. So, thank me later.
Making a real-life connect in the teaching of physics is of utmost importance. The simple-to-do hands-on activities using low-cost material can be taken up to explain some daily life phenomena like total internal reflection, refraction of light, correlation of pitch of sound with the volume of water in the water bottle, diffraction of light, etc. Infusing real-life experiences in the instructions makes teaching moments fresh and enrich the classroom learning. ICT-driven pedagogy, multimedia classrooms make learning an enriching experience for the learners. The effective use of OERs, that is open educational resources, in the form of videos, simulations, animations, enhance the visualization, and learners gain an insight of a concept in a very short interval of time. Let's witness an example of an ICT tool in the form of PhET simulation on the topic bending of light. As an example, the simulation shown alongside is depicting the concept of bending of light in physics, wherein a student can explore various things in the simulation to understand the cause-effect relationship between physical quantities of concern with great ease. A lot can be witnessed in this simulation as to what happens to the path of ray of light as it goes from one medium to another. What is the impact of angle of refraction with changes introduced in angle of incidence? Besides, we can play around here by changing the density of the optical medium. So in this present situation, I have the incident ray placed in the medium called glass, going over to the medium that is water. We can here depict total internal reflection of light by changing the angle of incidence in the denser medium. And we can depict the children that as angle of incidence increases in the denser medium, corresponding to a given angle of incidence, the reflected ray is obtained. The ray never reaches the other medium, never goes into the other medium, but totally internally reflects back in the same medium. A lot more can be witnessed with this simulation, but due to crunch of time, I'll go ahead further. Another interesting example of ICT tools is the use of graphic interchange format, GIFs, in the teaching learning process, as it makes learners imbibe the multiple aspects of a concept substantially in a fraction of a second. The use of GIFs can boost the learning process and understanding of the 3D world of the learner and make concepts more relatable. As an example, the visuals of Young's double slit experiment and single slit diffraction pattern are shown alongside beautifully with GIFs. The use of Microsoft Excel or spreadsheets can supplement the understanding of various concepts related to physics. It can enable the learners to explore for a given data to how to plot a graph, a pie chart, it be a bar graph, or even gain further information by analyzing a quick given data with just a click of a mouse. Here's an instance where my students have used spreadsheets to plot graph, whether it be plotting a graph for angle of incidence versus angle of deviation for a glass prism, or it may be for object distance and image distance graph for a convex lens. Besides, a plethora of engaging online tools are available to supplement the teaching of physics. The adjoining slide is depicting an ICT tool named Padlet, where all students of the class can simultaneously pen their learning digitally through a common link shared by their teacher. Likewise, quizzes can be used as a tool to engage students enthusiastically. And last but not the least, Mentimeter can be explored to take audience poll, make a word cloud, check leaderboard, and much more. Dear eminent members and fellow teachers, with the inclusion of innovation in the teaching of physics, we can not only inculcate the habits of peer learning, collaborative learning, cooperative learning, but also as a consequence, lead to the development of 5 C's: critical thinking and problem solving, communication, collaboration, citizenship, creativity, and innovation, which are critical to 21st century learners. Thank you, everyone.
Thank you so much, ma'am. You have given a wonderful talk and shown some of the softwares from the school teaching learning.
Yes.
I cannot see any questions in the chat box. So thank you once again. Now, I would like to invite once again Professor Pushpa Bindal, Professor Kalandi College, University of Delhi.
Somehow. So I'll start again. I'll share my screen.
Yeah, please, ma'am.
Is my screen shared?
Yes, ma'am. It's shared now. Just go to the.
Thank God it is shared.
Right, ma'am.
Can you see my screen?
Yes, ma'am. Just go to the presentation mode once.
Yeah. I'm going. Just a minute.
Sure, ma'am.
Yeah.
Yes, ma'am.
Good afternoon, everyone. So I'm Pushpa Bindal from Kalindi College. So today I'll speak about how to aid the offline teaching with online tools. The aim of this presentation is to understand how we can apply the phygital model. And this is a very, very recently introduced term in the education sector. So basically how to apply this phygital model to education sector, which is a balanced mix of physical and digital education. It allows the educators to make teaching more engaging, interactive, and unforgettable for their students. In this presentation, we suggest a few means and ways by which online tools can be used to enhance the experience of offline teaching. So let us try to understand what online tools are available that can be used for offline teaching. The first and the foremost is WhatsApp. I think we have all forgotten to survive without it. It's a part and parcel of our life now. So what we can do with WhatsApp, we can make separate WhatsApp groups with students for each theory and lab class that we take, so that students can share their doubts and difficulties way beyond the teaching hours, and a teacher can address them easily on the same group. Teachers can also share their assignments on these groups. Teachers can also share the PDF of study material and also the previous question papers, which are, very, very handy and very useful to the students on these WhatsApp groups. These WhatsApp groups can be particularly useful during examination time, when the students are really stressed, and those who are studying at the last minute, they have so many difficulties which will remain unanswered. So the students can, they can basically write them on the WhatsApp group, and if the teacher is willing enough, she or he can definitely address those problems even at the late hours, and therefore help the students in scoring well in the examination time. Now, a very, very useful and very handy tool, and which is basically Google Apps, can be used for offline teaching too. So which apps does the Google have for education purpose? It seems a lot many of them. So let us start with Google Education apps. This is how an ordinary offline physical classroom looks like. We can have an online Google Classroom. I'm sure many, many educators have used this during the pandemic period. So where do you find this Google Classroom? In those 9 dots which you can see in any Gmail account. So you can launch actually a Google Classroom for each theory and lab class that you take, and this is how it will look like. What are the advantages? One can share the assignment process. You can share the, you can basically allot the experiments to the students on the classroom. You can give them assignments. You can assign them PPTs. And since there is no need of paper, it is also, good for the environment. It is a great commenting system. The teacher can comfortably, comment on everything which is uploaded by the students. Next is Google Docs. This is basically a documentation app. One can provide doc files. One can, design doc files. What are the advantages? When you work in a Google Doc, it is automatically saved. Many users can simultaneously work, evaluate, and comment on it. Teachers can add comments as and when required. These are particularly useful for student research projects when many students are required to, prepare a single document, and they need to know what the other person is writing. The teachers also need to know what the students are sharing. So it can be, corrected, and it can be, many people can contribute at the same time. So this is a very handy tool there. Next, we can talk about Google Slides. Google Slides is basically, they are used for preparing presentations. It is a web-based tool. When you work on it, it gets automatically saved. One can embed videos and other elements quite easily. One can work on Google Slides even in offline mode. And most importantly, the audio-visual aids like YouTube videos, etc., could be, made a part of the presentation, which makes the presentation very, very interesting, even in classroom. This will really, make the students engage in what you're teaching. So this was for the Google apps. We do have some other apps which can really help us for offline teaching. We have some quizzing apps. Why does one require these quizzing apps? This is an excellent tool to evaluate a student's performance and understanding whether what you're teaching, whether you're teaching in online mode or offline mode. You get to know whether what you're teaching is understood by the students or not almost instantaneously. It enhances a student's speed solving problems, and their concepts become clearer when they use these quizzing apps, because they also understand where they stand in their understanding. If they have difficulties, it can be almost, instantaneously addressed by the teachers. We generally use two quizzing applications, Quizzes and Kahoot. Quizzes is an online free assessment tool. It works on web browser, iOS, Android, and Chrome apps. It empowers the teachers to engage and motivate their students. It allows teachers to conduct student-based formative assessment in a fun-based and engaging way for the students. It can be implemented on a single student or a group of students, even a group of students sitting at different places. You can also shuffle the multiple choice questions in it. Thereby, the scope of cheating, is highly reduced. Kahoot is also a free student response tool for administering quizzes. It facilitates discussion, and it also helps in collection of survey data. It removes the adverse effect of traditional quizzes, such as the pressures faced by a student, the anxieties of a test, faced by a student, and delayed feedback, because, the effect warns out. If you get instantaneous feedback, you always work on it. But if you get it after a very, very long time, the, effect is almost dead. You don't feel that much. The design of Kahoot allows teachers to observe the real-time performance of students and provide timely feedback to them. However, students need to bring their own electronic devices, at least a good Android phone, in order to participate in Kahoot, and also one requires a good internet connection. Now, we can also, use beautiful graphic designing tools. Canva is one of them. Canva is a fantastic free graphic design tool. It allows teachers to design graphics, produce infographics, and also visuals for the pedagogical content. Teachers can keep students' attention for longer lengths of time during lectures if they are using colorful visuals and graphics in their presentations. One does not require any prior skills or experience for using them. It is pretty easy to use. In fact, the presentation that I am presenting is also made on Canva. Now, educators and students, they need storing and saving, you can say, apps where they can save or store their educational material. So we can talk about two such apps. First is called Pocket. It is also called a read it later application. Pocket is a social bookmarking service which stores, shares, and discovers web bookmarks. What makes Pocket beneficial is that one can quickly save a resource and access it whenever needed without relying on the availability of internet. When we browse the internet and locate a good article that we want to read later, we can always save in Pocket. It is a go-to, resource bucket. Whenever you need, you can simply access it whenever you want. Okay. Now, the other storage app that we can talk about is iBooks. Every iOS user enjoys this bookstore. You can share or you can store PDF files and also some books in the iBook library for offline viewing. You see, nowadays teaching, it is impossible to constrain teaching just during the teaching hours. We have all been working way beyond the teaching hours. So if you want to meet and discuss something beyond teaching hours, what to do? We have to use video conferencing tools. This is how we meet offline, and this is how we can meet online. I think many have used this device, Google Meet. Advantages, you can collaborate, you can take attendance, you can use Jamboard, you can use calendar, and you can share your screen for the presentation. This is not the only conferencing tool, you have many more. You have Zoom, which we are using right now. You have Skype, you also have WebEx. So, which one to use? Which one is better than the other? It depends on what is it that you want. What are your requirements? It depends on the duration of your meeting. It depends on your team size. It depends on how frequently you want to meet each other. It also depends on how many participants are expected to participate. Okay, that you can also choose the corresponding app which will meet your requirements. Some of them, allow annotation, some don't. So what are the challenges of, including online tools for offline teaching? The main challenge is that you require a very strong internet connection. Everybody who is using it, including teachers and students, they need to have individual electronic devices. You need to address the diverse background of students. They come from variety of backgrounds, and you should be able to communicate and deliver to each one of them, irrespective of their background. However, we all agree that it is the need of the hour, and all pedagogical strategies need to strive towards it. Sooner or later, they will have to be made part of what we teach, and it will definitely it is going to help all of us, the teachers as well as the students. So I would conclude this talk by saying that we have discussed the various online tools that can be used to aid the offline teaching. This was a finite list, small list, and many other speakers have talked about other apps or online tools available, and I'm sure the educators will get benefited and they will try to use them in their teaching. So thank you very much.
Thank you, ma'am. Thank you so much for such an insightful talk. There are no questions in the chat box, so I once again thank you. Now our next speaker is Mrs. Pragya Nopani, Coordinator BVN Anveshika IAPT. She is going to speak on exciting ways of integrating experiential learning in teaching learning of physics. Over to you, Pragya ma'am.
Thank you so much, Poonamji, and I'm delighted to be on my home ground. IAPT is my learning ground where I've learned everything from doyens who have been present here or outside today's session. So here is my presentation. I just will share my screen. So I hope the screen is visible.
Yes, ma'am.
Okay. So here is a scene from one of the schools, and you can see the excitement and the joy that is on everybody's face, including the teacher. But when I began with these demonstrations, I was myself very excited, and it was a beautiful phase where we made it into a kind of movement in Delhi that everybody gets involved in activity-based teaching, learning of physics. But then somewhere along the way, there was a realization that these occasions can only be, just to ignite the fire. But then how do we ensure that there is a deeper learning? And I began asking many questions to myself after starting with these kind of stage shows or student programs or teacher training programs, that after my class or after my demonstration or after my practical lesson, can my students do something more than just pass the exam? Can they design solutions? Can they collaborate effectively for conceptual understanding? Can they engage in deeper but prolonged scientific discussion? It is fine if you ask them to explain a particular concept, they will do that. But then can they engage in a scientific debate or a scientific discussion which is long? Can they think of pros and cons of the arguments which are put up by different people? Can they produce counter examples? Can they use the stage to excite an audience? It's okay, as a resource person, I do that. But can my students use the stage to excite an audience and make them get involved in the scientific discussion? Can they organize public events to engage general public in physics? Can they ignite a lifelong learning others by their own joy? So these were the questions where I was seeking to go beyond the surface pleasure and excitement and all that. So I came up with, in my quest for a solution, there were many designs of experiential learning that I tried out, and I'm just sharing those experiences with you if it is helpful to anybody. So first was physics on stage, of course, as I said, I began. But then we did it with a difference. What was the difference? See, all the class 11th and 12th students were given projects to do, even though in class 11th, project was not a part of mandatory requirement of the syllabus. But then we made sure that every student in my class did a project, and only 2 students could collaborate on one project, but not more than that. And then out of all those 80 projects, if I had 2 sections, then out of 80 projects, we selected some 20 projects to be put up on stage. But it wasn't that they had to just put up the demonstration part of the experiment on stage. Each child had to not only demonstrate, but they also had to think of 3 questions which will enable them to engage the audience in the hall in the discussion for finding answers to those questions. Believe me, it's not easy to think of such questions, which are not just simple explanations, which take you further and further and further down in the deeper ideas of that particular demonstration, different aspects of demonstration. But the students are obviously not matured enough in class 11th and 12th to be able to take every answer or every aspect highlighted by the audience and evaluate it for its correctness with different theoretical concepts. So we invited Professor Verma to moderate the discussion on stage. And there were 20 such projects, and each member presented the idea, the demonstration, and invited questions. And Professor Verma, on the spot, he tried to bring variations and then, of course, evaluated the answers of the audience. So now look at this particular demonstration where child is standing on a rotatable platform and with stones or eat in his hands, and other child is going to rotate him. And he will bring his hands near, and I omega is constant. And all of us know that how that is constant, and by bringing his hands nearer or farther, he can change the angular speed of rotation. But then Dr. Verma went further, and how he made this child who was rotating measure the distance at which he was holding his arm, and then on the stage, the moment of inertia was calculated then and there. So, students had a greater in-depth understanding of the concepts, how to apply it immediately. And this was a great experiential learning. And then this same topic of rotation was taken further. Now there's another child who's standing on the same platform with this cycle wheel and then demonstrating. Now, it's easy for a child to demonstrate and explain the rata-rataya answer that he has. But this is not the purpose of this. The purpose was to engage the audience so that there is a collective learning. And the children who are on stage, they also get to revise their own understanding of the concepts. And this is how this program was taken to another level. So again, we are exploring rotation at a greater depth. So this is again the cycle wheel, and the child is doing something, and Professor Verma is on the spot thinking of a variation, and the child is, he's testing himself whether he can do that or not, and then come out with another explanation or variation in his demonstration. Then physics through games, this is also another kind of experience where we encourage children to think of solutions. What kind of solution? Now, once we had Professor Verma's program, and Japanese ambassador was to be the chief guest. And we desperately wanted to connect with Japanese culture. So I gave this task to my students that let us think of some item which will connect us with Japanese culture. So one of the students had gone that year only to Japan to present his paper in a science fair. And he said, ma'am, they play Super Bowl Sukui a lot. That is one game I can think of which is easy. Now, another child here, this child, he thought of a variation. He said, but ma'am, let us change the material of this. In this game, there are lots of these balls, bouncy balls, which are floated in water. And you're given this scoop. This is a scoop in which there is a paper. This is a paper. And you put it in the water and scoop as many balls as you can till your paper becomes so wet that it breaks. So the child said that, ma'am, let us vary the material of this scoop. We can have one paper which is overnight soaked in oil and dried. And we can have ordinary A4 sheet paper. We can have newspaper. We can have filter papers. So the children are designing their own game now. And then as the audience entered the school gate, all the participants of some 50 different schools, they played those games in big, big tubs and scooped as many balls as they wanted to. And so they had a first-hand experience of the game when they sat in the hall. Then on the stage, but all of them played with ordinary A4 paper scoops. Now on the stage, we had 3 different scoops. One was with paper soaked in oil, another was filter paper, the third was A4. And then we invited volunteers from the audience and asked them that which scoop would you choose to scoop as many balls as you can before your paper becomes broken. So, and then if this ma'am, Vinita ma'am, has chosen one and sir has opted for one, then before they can play, we involve the audience in the questions that which one do you think this volunteer has made a good choice, or which one do you think is going to win? So these are the children who devise these questions to be asked from the audience. Now audience will answer that which one is going to win without any further explanation. The game is played on stage, and of course one particular scoop wins. Now those people who had voted for that particular scoop are made to say that why they thought this is going to win. And so now the discussion on which paper would win as a strength, as a stronger paper. And it so turned out that the paper which was soaked in oil turned out to be the best scoop of all before it got broken. Now I leave it to you to understand why that paper was better than other papers. But this, you understand how it made the children design a game to suit particular occasion. They were the ones who made these scoops with, चूड़ी से और टूटी हुई चम्मच के हैंडल से उन्होंने ये स्कूप्स सिर्फ 4 दिन में बनाए हैं. So they had at least 200 scoops prepared in just 4 days. So I think that all is ingenuity, how they will make things and how they will design games, how they will involve other people in their experience so that together we can have a deeper understanding of physics. Then this is another demonstration that I'm doing, but the joy is not in my doing. The joy was that this child wanted to know what will happen if we put a glass slab in path of this ray. So if we put the glass slab, does the focus shift or not shift? So this we are trying, and the child will also try after or she tried before me, something like that. But then while the students, when we are demonstrating, when the students have queries, they're trying to go deeper, they are most welcome to come and try their hands. And that is how with first-hand learning, by doing with their own hands, they deeper their understanding. Then another kind of experience that we tried to provide was through experimental challenges. Now, what were the experimental challenges? Now, first of them I would like to mention is a competition called Choose Your Hurdle. And we have just floated this competition again on IAPT groups open to schools of Delhi and NCR, in which you have to design a setup to take a laser beam from point A to point B, but not directly. If you light a laser torch, obviously the beam is going to go from point A to point B. But the idea is to put as many hurdles in between point A and B. So what kind of hurdles? Exploit as many optical phenomena as you can to design optical hurdles, causing multiple deflections of the beam, but a part of the beam must finally reach point B. The more the number of phenomena, the higher is your score. So now children had to design what hurdles, whether it will be showing deflection by a prism or by a lens, or it will be refraction or deflection, or will it be diffraction or interference or anything else. So this was the prize-winning setup where they had shown 11 optical phenomena. And sadly, this child on the left passed away recently. So in his memory, we have again floated this as a competitive event. So I'm sorry, I'm not able to discuss in detail the wonderful ideas that children brought in. But here is a picture of some of the designs that they had to show us. So they are putting everything that they studied in theory into practice. All the phenomena, optical phenomena that they've studied from class 10 to 12, they are going to be able to actually put them into practice and first-hand experience, of course. Then another experimental challenge we gave was, you take a thread and tie up these 5 washers in such a way that when you drop the thread, the washers strike the ground after equal intervals of time. Now, this children can do this only if they've understood the equations of motion, especially the second equation of motion, and it's working properly. S equal to ut plus half at square. When will the washers strike one after the other at equal intervals of time? How much distance the ratio should be there between them? If the children have understood that equation, they will be able to do this challenge. Then in class 12, we used to have an experiment on meter bridge where they had to verify the laws of series and parallel. Now, one of the complaints of students about physics lab is that all the experiments have a predictable result. There is no mystery. The physics lab has the chemistry lab has so much of mystery कि कौन सा उसमें आयन निकलेगा, कौन सा कंपाउंड निकलेगा, but physics lab में तो सब कुछ हमें पहले से पता है. तो मैंने कहा कि अच्छा ठीक है, आप एक काम करो, मैं आपको I'll give you 3 keys, just single keys, and you design a setup so that never once throughout the experiment you have to take out any resistance. First they take the value of R1 using meter brace, then they find the value of R2, and then they take it out, and then they put again the series combination of R1 and R2, and then they put the parallel combination. So I said, no, you just design a circuit so that you never have to take out any resistance. So, and then after you design that, do the experiment both ways. Once by removing the resistors one by one, and the other by inserting those keys. So this is the design they came up with. And you can see by plugging in one of the keys, you will have some combination. You can have only R1 in picture. Then by plugging, supposing you plug in K3, then you will have only which one in picture you can make out from here. Now, when they use the keys to perform the experiment without taking away the resistors from the circuit, and then without the keys, and when they tallied their results, what do you think, when was the result better? Obviously, when the keys were used, because this design ensured that every time the length which was used in the circuit was same. The length of R1, the length of R2 was same every time, whether they were used individually or in series or in parallel. So this is how they were able to get a deeper understanding. Then another one we did was that while studying optics, one of the children brought a newspaper clipping that birds get scared of light reflected from mirrors. So, and somebody had made a reflector for birds so that they did not eat away the saplings. And this was the design, that there is a football kind of thing, globe, on which mirrors are stuck, and this is rotated. And when it is rotated, the reflected light will confuse the birds and they will not come near it. So we said, okay, let us do this ourselves, and we named it Crystal Crow Confuser, CQ, Crystal Crow Confuser. But then I said, okay, now you have to tell me what is the optimum height of this globe from the bottom, or what is the optimum rotational speed for which it will be most effective for the for scaring away of the bird. So you don't have to do the experiment, but you design an experiment which will enable us to find the optimum height and optimum rotational speed. And to my great pleasure, one group devised this solution. They had these circles of grain. गेहूं के grains उन्होंने ऐसे circles बिछाए, और फिर इसको अलग अलग हाइट पर चला के देखा कि किस में उन्होंने नियरेस्ट किस हाइट पर सबसे फार्देस्ट सर्कल के ही गेहूं खाए थे और पास वाले नहीं खाए थे. मतलब उस पर्टिकुलर हाइट पे वो वाली दूरी जो थी, दैट वाज द इफेक्टिव रेंज. और फिर इसी तरह से रोटेशनल स्पीड भी उन्होंने टेस्ट किया. सो दिस इज हाउ दे डिजाइन्ड एन एक्सपेरिमेंटल प्रोसेस to find the solution to a problem. Then collaborative learning हम किस तरह से हम करवा पाए? One was this again a stage event. Then there was light. So what was the event about? We gave these 4 lines and asked the children to present a shadow play inspired by the lines. Which are these lines? There was a lady called Bright who could walk faster than light. One day she went for a walk in a relative way and came back the previous day. Well, how do you walk so that you come back the previous day? Obviously, you have to walk faster than light. So here is a superwoman who can walk faster than light so that she reaches a spot before the light is able to reach. So the children had to interpret these lines in whatever way they wanted to and write a shadow play, write a play, screenplay, and then present it on stage as a shadow play. And we said that the act should convey a clear message or a theme. And one screen of white cloth, the size was given to them, and one stage light हमारे स्कूल में पड़ी थी पुरानी, वो stage light हम आपको दे देंगे. And at least one light source used in the shadow play must be designed and made by the team itself. The timelines, that is the total presentation on stage, including introductory commentary, should not exceed 15 minutes. The total team size should be between 6 to 12 members. Now, this was given house-wise, so that children starting from class 6 to class 12, all could be part of this shadow play. Everybody starting from class 6 to class 12, everybody has studied shadows. But can they put the concept of shadows into practice? Do they understand that where they should keep the stage light so that a particular size of shadow of a particular object will be created on the screen? How to increase or decrease the size of the shadow by changing either the location of the light or by location of the object? How they will change the angle so that what appears on the screen is not the actual shape of the object. For example, if you look at this here in this photograph, this boy is speaking in a mic, but this mic and this is supposed to be the table. But actually, this is a girl who's raised her hand so that this looks like a mic. So the children had to learn what kind of shapes are going to look like what on the stage. Now, I was amazed to see their presentations. One of the groups interpreted these lines as being about a superwoman who had ideas much ahead of her time. And so people did not understand her properly and they criticized, many were jealous, but she takes it in a stride, she's a superwoman, she can take anything. Her ideas are revolutionary, like walking faster than light. And other people are envious. So now what these people did was, they wanted to show how other people are envious, how other ladies are envious of this lady. So what they did was that this lady with super revolutionary ideas, her shadow was very tall and the others were smaller. And then in a plate, they put KMNO4 and poured glycerin over it, and this caught fire. And they kept this plate in front of the chest of the smaller shadows. So it looked as though कि एक ईर्ष्या की अग्नि धधक रही है उनके heart में. So they not only fulfilled the condition of having an indigenous light source prepared, but they were able to very effectively show that ईर्ष्या की अग्नि. The other play was about a scientist who devises a
I think there is some network glitch. Ma'am is not audible.
I'll just start.
Yes. Yeah, I think ma'am is, there is some network glitch. So I request so now I request Professor Pushpa Bindal, Professor Kalandi College, University of Delhi, kindly give the another talk, which the title of which is Learning by Doing: A Gateway to Concepts of Physics.
Thank you, Poonam. So I share the screen once again.
Yes, ma'am.
I think. Let me close. Just a minute. Yeah.
Ma'am, you are not audible.
I'm not audible.
Ma'am, voice is a little low.
Okay. I'll check.
Yes, ma'am, quite better. Ma'am, please share your screen.
So I'm not seeing my screen. I thought I shared. Just to go there.
Ma'am, still not audible.
Is my screen shared?
No, ma'am, screen is not here.
Okay. I'll share it once again, I think. Is my screen shared now?
Yes, ma'am, screen is here.
Yeah. Okay.
Ma'am, kindly go to the full screen mode.
Yeah, I'm going. I'm just going. Just a minute.
Yes, ma'am, fine, ma'am.
Yeah. So, hello everyone. So here I am presenting another talk on experiential learning. The title of my talk is Learning by Doing, a Gateway to Concepts of Physics. Yeah. This is on the theme Experiential Learning and Integration in Physics. Here we aim to study how one can evolve as a physicist and routing through experiential learning. Experiential learning makes teaching more engaging, interactive, and unforgettable for the students. So in this paper presentation, we suggest how teachers can design and demonstrate simple experiments in their classrooms too. See, why we want it? Most of the time, there is a gap between the teachings of a teacher and the learning of a student on the same. What teacher thinks that he or she is teaching may not be seen as what is grasped by the student. Knowledge imparted by the teacher is not exactly same as received by the student. So, experiential learning is an effective technique to reduce this gap in understanding. This is part of new age pedagogy and learning techniques which did not exist or existed only in the basic form earlier, now are available. Instead of being the teacher-centric, this type of learning is mainly student-centric. So let us see how the two types of learnings compare with each other. Conventional learning versus experiential learning. Conventional learning is mostly predefined, theoretical in nature. It has a fixed framework. It involves transfer of knowledge from teachers to students. Whereas in experiential learning, it is open-ended, it is flexible, it can be customized, and knowledge is usually developed by doing, not just by transfer. It is a holistic model of teaching The Indian education system is heavily inclined towards rote learning, but slowly experiential learning is making a place for itself in this system. The experiential learning helps retain the knowledge forever. In fact, it is scientifically proven that experiential learning helps enhancement of memory retention by 29 to 42%. It involves laboratory work as per and also beyond the syllabus. It involves applied studies and one could perform doable small-scale classroom experiments. It enables both the teachers and students to become tech-savvy. It provides them with an opportunity to enhance their skill set. Students are actively engaged in posing questions, investigating, experimenting, being curious, solving problems, assuming responsibility, being creative, and constructive meaning. It is an integral part of physics education and can definitely lead to better clarity of concepts of physics. Now, few ways by which experiential learning can be made an integral part of physics to understand it with more clarity are demonstrated here. The first and the most important, most important tool for experiential learning is using the audio-visual aids. We know that at times classroom learning can be quite monotonous. We can increase the students' curiosity if we complement the standard study material by employing multimedia, presentations, simulations, YouTube, as well as we connect the subjects that we teach to everyday happenings and items. We can utilize these technologies to ignite the interest of the students in real physics. This is, I do believe, and we have seen so many presentations today, so many talks we have attended, that it is good if the teachers could, develop their own video and e-content, which helps the students in learning faster, which gives them an experience along with the standard classroom studying and learning. But however, not everybody is so tech savvy. So we do have some, material available online. One of the very, useful technique is we can use some videos uploaded on killer visualization. Physics is fun. Here, basically this guy demonstrates concepts of physics along with the experiment. You see, he is explaining which one is a converging lens, which one is a diverging lens, which people tend to get mixed up. And the way he is demonstrating in this video, one will never forget which one is diverging and which one is converging. So it is not just this is the reference, YouTube link, which is demonstrated at the bottom. So many, branches of physics are well explained with the help of simple videos here. The concept of magnetization, they are well explained by burning matchsticks, how the basically magnetic material sticks and how it is attracted towards magnets. So one can easily learn the basic concepts by demonstrating these videos along with the classroom teaching. You do have good material on atmospheric physics as well. Fluid mechanics is also beautifully explained by, inverted bottle experiment. So one can easily, refer to this while teaching. Newton's first law of motion, inertia, the body tends to stay in the state of rest or uniform motion. This is very well explained in this video. And not just these there are many more available there. So we can refer to these while teaching in the class, and that will make the experience memorable for the students. We can organize quiz competitions in the classroom itself. 10 to 15 minutes of quizzing via polling will get the students genuinely interested in the subject. It encourages them to perform better in the class due to immediate results. They get an instantaneous feedback from the teacher, and therefore, they evaluate, they are able to understand whether they have truly understood or not. Now, physics labs they are, they form a very, very integral part of learning. In physics, working in physics labs is indeed a very self-learning and concept-forming experience for students. If we inculcate a combination of virtual labs and physical labs, it's a deadly combination, very, very enriching. It gives a good grip over the fundamental concepts. For example, supposing we are dealing with mechanics lab, we're taking mechanics lab for the students. So students perform experiments like bar pendulum, Cater's pendulum. They do it in the lab, a standard instrument is there, right? But they can only perform that with certain physical parameters and only on Earth. Whereas, simulations are available on various virtual platforms like Amrita V Labs, Colorado website, IIT website, where the students can simulate that experiment not only on Earth, but also on other planets like Jupiter, Moon, etc. This is a standard Viva question for the student, that if you perform the same experiment on, say, Moon, what will change? How will it affect your reading? So the students can actually do it and see how the time periods change and how the ultimate calculation of G changes. So it gives them a real experience and they will never forget it. So similarly, on FEC Colorado website, which one other speaker showed, it is possible to perform a mass and spring constant experiment, and it is possible to see the effect of changing spring constant. You just move your cursor and you could change the spring constant of the spring which is being used in the simulation. So you can see how the oscillations of mass and spring will change as you change that. And one could make the virtually the series and parallel combinations of these springs and see what is the effective spring constant. In fact, at least in DU syllabus with NEP, these are being introduced in reality in physics labs. And, they have to be complemented with some online tools. It is part of the syllabus. So we really can't, escape it anymore. It has to be inculcated in our regular teaching as well. So if we include this in the regular lab work, maybe as an assignment, maybe as a part of continuous evaluation, this will enhance the students' understanding of the experiments manifold. This is a simulation available on Amrita website. This is Cater's pendulum. You do have other experiments available which can be used. Similarly, when the students are working in electronics lab, they are making electrical circuits. So they can visit V Labs on IIT Kharagpur and IIT Bombay websites. And there are many, many experiments, simulations available there, where the students could learn to assemble and work with electrical circuits before they actually do it in physical labs. To avoid any injuries or burning of the equipment, they can also make permutations and combinations of the parameters available, and it gives them a deeper understanding of the subject. For example, this is an experiment, this is a simulation on Norton's theorem available in IIT Kharagpur website. Similarly, EMT lab, the students generally perform EMT experiments in 6 semesters. But they could perform, they once again, they perform experiments with a particular material, right? So on EV labs, they could perform same experiment. The same simulation is available for variety of materials. So some examples are, for example, they could perform the booster angle experiment with not just glass, ordinary glass. They could perform it with topaz, plate glass, crown glass, and they could see how the booster angle changes with change of material. So it gives them a real feel about the properties of different materials. Boltzmann constant experiment. In class, they just are asked to perform with one given diode, okay? But they could perform the experiment with a large variety of semiconductor diodes on VLABs, and it gives them a good feeling about the dielectric properties of the material which they are using. In optics lab, beautiful simulations are available on Amrita V Labs for spectrometer-based darkroom optics experiments, and the students could learn them virtually before performing them in the darkroom V Labs. In fact, they could learn to evaluate, understand the least counts of spectrometers and how they could understand the concept in a much clearer manner before they actually perform in the darkroom. So it gives them a good grip over optics experiments. This is an example of electromagnetic spectra experiment, once again available on Amrita website. This is a Newton's ring experiment simulation available once again on Amrita. Now, we could, we can talk about some more experiential learning examples. Now, in classroom itself, while you're teaching, you could, design and perform some doable experiments in the classroom itself, and that would make the experience unforgettable for the students. For example, slits, circular apertures, etc. We could make them in aluminum foils, and we could also, make them with the help of razor blades. You have to basically use sellotapes, etc., to achieve the aperture of desirable dimensions. And you could subject them to laser pointers. You could make the light coming out of the laser pointer, on these apertures, and believe me, you can see beautiful diffraction patterns on the classroom walls itself. Now, for example, this is demonstrated here. You could make a single slit with the help of two razor blades. You could use sellotapes to basically put it together, and this would make a good single slit, and this is a corresponding diffraction pattern. This is described here how to do it, and you can see diffraction fringes, and this is very, very appealing for the students. Actually, we have done it. I've done it myself. This is a single slit diffraction pattern which I made with the help of razor blades, and again using a laser pointer, and you can see one can show it on the wall of the classroom, and the students will really get interested. This is a double slit diffraction pattern. Again, it was made with the help of razor blades only. And this is a circular aperture diffraction pattern which I made. I made a very, very tiny circular aperture in a paper cup, normally used for coffee, etc. And just expose that to, you make the light coming from a laser pointer fall on it, and you can see this airy pattern, okay, on the wall. So people might forget that this is called airy pattern, but they will never forget this diffraction pattern. This is diffraction pattern of a rectangular aperture. Once again, it was made with the help of razor blades, and you can see such a beautiful diffraction pattern. So another, aspect of experiential learning could be introduce students to research, research and engage them in student research projects. If you engage them in small projects, it encourages them to think and learn independently. They get a flavor of research, and they tend to learn more techniques for studying, documentation, programming, and presentation. It fosters critical thinking and analytical skills in the students. It defines their academic career. It defines their personality. It expands their knowledge and understanding beyond the classroom. It develops a one-to-one connection with their teacher and, even with subject experts. So what are the challenges of including experiential learning in your regular learning? Once again, they are more or less similar, which we have discussed before also. You need smart classrooms. You need strong internet connection. You need good electronic devices. You need to address the diverse background of students. Once again, it is the need of the hour, and we must include these in our regular teaching to make the teaching very, very appealing to the students, and we must strive towards it. So I conclude this talk by saying that we have discussed how to integrate the experiential learning in physics teaching. Thank you so much. These are some of the references.
Thank you, ma'am. Thank you for giving the insight of the experiential learning in physics. I also want to thank Pragya ma'am. At the end, she was disconnected because of some network glitch, but that was wonderful experience, ma'am. Hands-on experiment you have showcased here with the help of pictures, and I have attended 2-3 sessions myself of yours through IAPT. and it is really, worth learning, experiential learning through the experiments. Thank you so much. Now at the end, I thank all the speakers and paper presenters for enlightening the audience with their knowledge. Tomorrow, we will again have the session from 10 a.m. onwards with more interesting lectures and more innovative experiments. I hope all of you will join it again. Till then, stay tuned. Thank you, everyone.
Thank you, everyone.
Ma'am, may I stop the end the meeting?
Yes, please do.